All right, we in there. Let's do the thing. Let me know how my audio is coming through on the Twitch stream because I've been, doing bad things and resetting it, and I just, it's okay. So if I need to be
I
higher,
don't hear any audio so far.
you won't hear it until like another couple seconds because you're on delay.
Oh, you exist now. You
Yeah,
just like appeared right after you
I
said that.
just appeared. That's right.
You just appeared in the corner.
Let me know how y'all like how everything sounds. My audio, your audio, all the things. Trying not to be low, but okay. I just raised the gain a little bit. Let me know if that's better.
Yeah, I feel like the sound was quiet as of however many seconds ago.
Testing, 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 testing. Oh, that sounds. I guess I'm supposed to be like having this mic right up in my face, and like speaking right into it and yelling at it. But it sucks because when I go from my desktop to my laptop and then like I'm on Zoom or Google Meet or whatever, everything's just different, and it's everything calls for slightly different gains. All right, ready to rock? Let's do this book club, right? Isn't that why we're here? Let me go find wherever I put this book. Okay, what are we on? Chapters 9, 9, 10, 13? Is that what I remember?
Yep, I wrote the chapters down really oddly this time around, but
Oh, it's all
it
good.
starts with access to the cloud in chapter 9, and then it ends at the end of chapter 13. So 9, 10, and 13.
Oh, didn't I say that I was gonna like show you Oxide Cloud? Didn't I say something like that last week? Okay, let me be a good person. One moment, please, while I do my thing. Do you all have any questions first while I get my stuff set up over here?
This time around, like I felt like because I've never dealt with networking and like this kind of stuff like with anything apart from like setting up, I guess like routers and stuff.
Right.
So where you just have to like put in the IP4 v4 or like whenever you're setting up like a Wi-Fi stuff. Uh, so this was like meaty in many ways. Um, so like you were like since you have like, so much experience dealing with this kind of stuff, and I'm sure you like work you know with setting up different networks and stuff. Uh, I'm gonna ask like I don't want this thing to just evaporate off of my head. So what do you think is like a small good project for me to like just like kind of go through for just so I can like utilize not all of it, but maybe 30-40% of whatever's in there.
So you're specifically talking about the networking chapter, right? Chapter 13.
Yeah, the network. Yeah, networking chapter. Yeah,
Oh, okay.
like
Yeah.
the packets. Yeah.
Um, I don't remember exactly what it covered. Let me just look. Yeah, packet routing. Honestly, there's no like project that I would recommend specifically.
Yeah.
It's more about like just going over the concepts, right? Like understanding that your computer has like understanding the different layers of networking, like the 7-layer model, and understanding like what those layers mean and what operates there. And it's really layers 3, 4, and 7 are like the kind of important ones there.
Mm,
It's hard to say like here do a project. I mean, you can write your own web server, right? Like you can like spin up a web server, and you could even do a raw web server using TCP and like try to implement the HTTP protocol yourself. Like that'll probably
mm,
help teach you like what the difference between L4 and L7 is. But like VLANs and routing and MAC addresses and all this other stuff, that's
yeah.
going to be more difficult to learn in like a project. You kind of have to like set up your own network you know?
Hmm. Okay. And you said like 7 layers? I thought there were only 5.
Depends on what layer like system you're talking about. Some people call, what is the squeaking sound? The squeaking sound is my dog playing with toys. Where can I find this book? This is O'Reilly book, right? What is this book, O'Reilly?
Yeah, I have it through O'Reilly.
Yeah, it's I'll send you the link is actually in the
I see.
description. Yeah, the link's in the description for the stream,
Hi,
so you should
DJ.
see it. Cool. Yeah, so like the 5-layer model is the TCP/IP model. So layer 1, 2, 3, 4, and 5. And do they show it here in the book?
Yeah, it's like on page, it was 379, I believe.
Yeah. So this is like the common 5-layer model, but it's not like the that's just one of the models that people like refer to.
Okay.
If you look at the OSI 7-layer model, that is another model that people kind of refer to. And I'll put this up real quick. Like here's the 7-layer model versus the 5-layer model, right? Like generally speaking, we combine kind of layers 5, 6, and 7 into one layer called the application layer, but they are technically 2 other layers if you want to get technical about it and argue with someone on the internet.
Okay. Got it.
Which layer is the one? Like is it layer 4 that would be like say I want to filter out specific IP addresses on like an Nginx server? That'd be layer
If you
4.
want to get technical about it and argue. Which layer would that be?
Mm-hmm.
Oh, the freaking mangled my description. Sorry. The restream mangled my description. Let me fix that real quick because I had it set up so nicely. One moment, please, while I, do things. Okay, check out the description now. It should have had it set up so nicely. The book. You can find it on O'Reilly, but that's the book name. And sorry, Jacob, ask your question again.
I was wondering, like, layer 7's like app layer makes sense, but like layer 4 is the other one we typically talk about, right? Like, say I have an Nginx server and I'd like to filter based on IP address, something like that. That'd be layer 4, right? Or am I wrong?
If you want to filter on it, you say?
Yeah.
That would hard to say. That would kind of be layer 3 and layer 4. Like, so layer 3 generally handles like the routing aspect of it. So if you're doing like filtering or any sort of routing things, then that's going to be handled by layer 3. If you're listening on a socket, then generally that's layer 4. And if you want to like kind of, if you have like if you have 2 services listening on different sockets and you want Nginx to kind of like proxy that or whatever, then yeah, then you're speaking L4. But you're not really filtering there technically, I guess. Depends on what you're doing. Happy to answer like follow-up questions on it though.
I don't think I do. I just was wondering which ones were, yeah, just like the numbers that we normally talk about, because I know there's more that we focus on, or at least I focus more on as like a web developer rather than like sysadmin.
Yeah, I mean, I mean, I didn't expect to jump I didn't expect to jump to chapter 13 just yet. I thought we were going to go kind of more in order. But since we're here, I'll like really quickly go over these because I think it's helpful and kind of give examples. So you have the 5-layer model or the 7-layer model, right? I traditionally use the 7-layer model because that's kind of what I was like taught in, when I studied networking. But that's 5, 6, and 7 layer can be combined into one layer called the application layer, right? So we'll just use this book's 5-layer model. But like, we'll just go up. So the physical layer, like what's important there, right? Like what do you actually, you as like an administrator, what do you care about? And let me get this, I want to get my terminal up. Yeah, there you go. What do you care about as a system administrator at each of these layers, right? So layer 1, you really only care about the physical actual thing that you are using, right? Your Ethernet cable, your copper cable, your fiber cable, even the radio waves emitted by your Wi-Fi access point, all of that stuff is layer 1, right? The physical way of how electrons and stuff or light go from one place to another, right? Generally speaking, as engineers, administrators, we don't care about that, right? Like that's just like, that's for physicists essentially at that point. But we plug in a cable or we connect to a Wi-Fi network, physical. The link layer, layer 2, that's where the devices that are on that link can identify one another. So layer 2, you're generally speaking about MAC addresses. So looking at my system here, I have a MAC address on my Ethernet port, right? On my physical layer, or on my layer 2 NIC, I have a MAC address here, right? I'll make that a little bigger. F0, blah, blah, blah. This is my MAC address. So if 2 devices were connected over the same physical layer, the MAC address can be used to identify which device is which. For us, we need to be able to identify, like to network multiple computers together. So we move up the layer into what's called the network layer. And here is where we introduce a new way of addressing called IP addressing. So now if you want to identify a system, like on the network, right? Not just like a physical port, but if you want to identify a system, you're going to use its IP address. And under the hood, an IP address and a MAC address are linked, right? My network switch in my home network here only knows that my computer has this IP address because its MAC address and its IP address are linked in what's called, I believe, the ARP table. I don't remember how to show everything here, but you can see like, hey, this address has this MAC. And that's how a switch knows where to send packets or technically frames of that layer to different devices on the network, because it uses this MAC address to IP address lookup. And it's like, oh, I've seen IP address .228 before. It's on that MAC address. Send the frame that way and let it deal with it. I'll stop there for a second. Any questions so far? I forgot all the ARP
layer
commands.
is taking, like, it has the IP address and it's trying to route to the correct MAC address at that point.
Say that one more time.
So with ARP, it's taking it has the IP address and it knows what maps to what what IP address maps to what MAC address at that
Correct.
point.
That's how, like, when there's a really good diagram. Hold on, let me find it. There's a really, really good diagram that I want to show you all. If this loads well, this will work. Nope, of course it didn't load well. That's malware. That shit's malware, dude. Hold on. I had it when we were going through. Yeah, this is a really good diagram. Okay, I'm gonna open this up over here. Can you all see this diagram? I think this helps tremendously into understanding networks. So if I had to show someone like networking and like talk to them about it, I'd pull up this diagram and walk them through it. I'm device A, right? And let's say, Jacob, you're device B. And let's say you and I are separated by 2 routers, right? Two routers separate us. So we're like 2 hops away from each other. The process of how data from my device moves to your device is like this. I have an application. Let's say that you and I are both speaking using the foo application, right? To speak the bar protocol or something, whatever, it doesn't really matter. My foo application will put some bytes together and it'll send it down the OSI layers essentially, right? It'll package up those bytes. It'll tell my computer, it'll say, hey, computer, I want to talk to device B who lives all the way over there on the other side, of the network, IP address 1.1.1.1 or something. So in layer 4, it'll be like, oh, I want to communicate with Jacob's device who lives at IP address 1.1.1.1, port 123. So I want to communicate with that device. It'll take the bytes that I put in my application layer, wrap it up into a like TCP segment usually, and say, okay, great, I know where I want to go. I'm going to pass this down to your network interface on your NIC, right? The NIC is going to say, oh, I know where to like send this IP datagram off to. I want to send it to IP address 1.1.1.1. The network layer will then wrap its IP like data on top of that. And it'll say, I don't know how to directly deliver this to Jacob's 1.1.1.1 IP, but I do know the next hop, and the next hop is going to be this router, this next router. Layer 2 is going to say, oh, I don't know where Jacob's IP address 101.1.1 is because there's no MAC entry for it, but I do know that if you want to send to the next router, I do know that one's MAC address, and that MAC address is ABC. I will send that to ABC, and then it sends it over the physical layer, right? And then it makes it to that first router. That first router is like, yes, I am ABC. That's my MAC address. Yes, I am not 1.1.1.1, but I know how to get there. And it'll repackage the packet up, send it back down the data link layer, say, oh, you need to go to the next router. The next router is DEF. This next router gets the packet. Oh, yes, I am DEF's MAC address, but I am not 1.1.1.1 IP. Let me package that back up, send it to Jacob, and I know where Jacob is. Your system will finally get that packet, and it'll say, yes, I got it on the physical network. Yes, my MAC address is whatever, it doesn't really matter. Yes, I am IP address 1.1.1.1. Great. I'm going to open that up. Oh, you gave me data for port 123? Yeah, I know where port 123 is. That's my foo service listening. Unpackage that, goes up to the application layer, takes all the bytes out, and reads it. And that shit is happening thousands or millions of times, throughout the life of us communicating. Sorry, I know that was very long-winded, but that's essentially what's going on.
So
And
then
if
this is
you're
all
on the
very. Oh, go ahead.
Oh, go ahead, Jacob. I'll go after you.
Okay, so this is all very trust based, right? So like if I'm like a malicious router and I'm like, hey, actually, the address you want is at this really cool place that's my own server. Let's go there. Could it just do that?
Yeah, it could totally do that, right? Like if I put a server on my network or on the network that this first router is attached to with IP address 111 and I put a route in that router, then yeah, it'll go there, right? Instead. Like that is for sure. It's no different than like me going on anyone's network and saying, "Oh, yeah, I'm going to redirect google.com to this local machine because I have access to your network." Like there's nothing stopping anyone from doing that, for sure. But the way like we get around that on the internet is the routers that carry traffic across the internet they have to like apply to be what's called like an autonomous system, an AS, like an autonomous system zone or whatever they call it. And those have to go through like kind of an organization to get a AS number and then to be kind of trustworthy. And then only after that happens, then other routers will be like, oh yeah, I trust you as a router. I'll share my routes with you. And that's kind of how the trust is built on the broader internet. That big Facebook outage that happened a few years ago, where their routes were wiped from the network, they made like a bad BGP config. BGP is Border Gateway Protocol, which is how routers like talk to each other. They pushed like a bad BGP config and basically erased their own routes from the internet. And all the autonomous systems were like, Facebook, hardly knew her, and they kind of erased each other's routes. So that's kind of how like trust is built on the internet as a whole.
Okay, makes sense. Go ahead, Brett.
Yeah, I was just gonna ask, so if you're in the same local network, let's just take for instance like a local home network. If you have the MAC address of, let's say, let's say my iPad, and I'm on
Mm-hmm.
my Mac, I can I can communicate if I know that device's MAC address. I don't need its IP address, correct?
I mean, you can communicate using
Or
layer 2 frames, right? Like you can send
okay.
like raw data across to it, but that data is probably useless if like no IP is listening on your system to like receive the data, right? Because there are other protocols
Mm-hmm.
than IP, right? Like the data, the physical layer and the data link layer, that's just sending the raw data over the wire. Then something has to be listening on your computer to like take that raw data and make it meaningful. And usually that's like your network layer because there's an IP address listening and to receive that data. But you don't have to have an IP address. You can have some other L3 protocol that's not an IP. Like you can implement your
Gotcha.
own, yeah. You can implement your own L3 protocol if you wanted to, technically. But then you
Cool.
would probably have to write a low level network driver for it so that it knows what to do and blah blah blah. And you get into very, very big complexities very quickly.
Gotcha. Cool.
To give a brief summary, because I think this helps a lot of people, layer 3 deals with like IP addresses. That's basically saying what device on the network should I be communicating with, right? That's what we're saying. When I go to google.com and I get its IP address, I'm saying, oh, google.com is this IP address. That's who I want to communicate with. So that's saying what device on the network am I communicating with? And then when you think of the internet, it's an internetwork, right? That's what it means. Many networks, like many networks connected to one another to form an internetwork or the internet. So when I go to google.com and that DNS name gets translated into an IP address, I'm saying that's the device on the broader internet that I want to talk to. Then L4, when you bring in ports, right, TCP ports and UDP ports, you know how port 80 is HTTP and port 443 is HTTPS and blah, blah, blah. That's now saying what service you want to talk to on that device. So when I go to like, 1.1.1.1 port 80, I'm saying, hey, I want to talk to the device 1.1.1.1, and I want to talk to the service who's listening on port 80. So now you're identifying a specific service on that device. And there's like 65,000 ports that you can bind to on a machine. So you can have like, that many services per TCP and UDP. So that's how like the addressing works. How did we get on this topic? I don't even know how we got on this topic. Oh, let me look at chat. Doxing me. You've always been doxed. Any other questions on networking? I know Dev brought this up, I think, right? But he said he had to be right back.
Yeah. Most of my questions are on this, but I feel like, I mean, if you want to start from cloud and move on, either
Yeah.
for me.
Let's go back to cloud and we'll come back to this. I didn't expect to jump to networking yet, but it's fine. Okay, so you said we're really supposed to be starting on cloud, access to the cloud.
Yes.
So chapter 9, cloud systems and such. Does anyone have questions on chapter 9?
Did you show your coworkers the chart?
Which chart?
The one that
Oh, no, I
showed
didn't. I
this
got to
was
show that
about.
too. Yeah, I remember now. I didn't because I got really busy. This one? Yeah, I'm going to show them this chart. This is funny. Can be expensive, complex. Has a history of outages. I still find this funny. But yeah, anyway, any questions on the cloud? Does anyone know what the cloud is? Does anyone know what a VPS is? Does anyone any questions on this part? Does anyone
So,
know?
so I
Go
have a
ahead.
question. So, you asked if anyone know where the cloud VPN is. So, now I'm curious. Where is the VPS from, or how does it consist of?
Yeah, so the idea of like the cloud is that there are companies running servers for you somewhere in their data center, and they're providing access to those services and servers over the internet, right? So we call that like cloud systems because we're accessing it from anywhere as long as you have an internet connection. The term VPS, and I don't actually know who started the term VPS, to be honest with you. I don't know if the book even says it, but the term VPS means virtual private server. So it's a term that was given to say, hey, when you spin up a server on my cloud platform, this server is a virtualized instance, meaning it's running as a virtual machine, so on some physical machine somewhere, and it's private to your account, so nobody else can access it except for your account, and it's a server. So it's basically just saying, oh, you need a Linux box on the internet somewhere? Great, I have a server for you. Here it is. Here's a VPS. And that's what a VPS means. A very popular cloud platform that provides them is like DigitalOcean. They're like a very popular VPS provider.
I see. Thank you.
Yeah.
Thank you.
And it's really no different than like, you know, AWS EC2, which is called Elastic Compute Cloud. It's a way of giving you access to virtual machines over the network, and they're also called virtual private servers, essentially.
Gotcha. Yes.
Any questions on clouds?
I had a quick clarifying question. So I think it's on page 291, cost control.
Yep.
Maybe it's just clearing up my confusion. So it's that third bullet point, block storage volumes. Is that just almost like rented space of a hard drive, if you will? Like what is block storage volumes?
Yeah, that's a really good question. Generally, when we talk about storage, we talk about storage in two ways. We talk about it in terms of block storage, which means that storage, like the data is written to block devices, right? In blocks, in chunks at a time. So if you ever heard the term like block size, I might be able to show you.
Like on the Nintendo Wii.
Permission denied. I show. So you see how like I have this disk on my machine. This is like a 4 terabyte disk that I have. It's chopped up, like it has this many total bytes on the disk, and it's chopped up into different sectors, and the sectors have like blah blah blah, like sizes and all that stuff. So
Mm-hmm.
this is like how hard drives are kind of chopped up for you. Then when you create a file system, like you can have a file system on that drive, and I think it's at the file system level or the partition level. I forget which level it's really at, but at some point you have to choose what's called a block size, right? And a block size just says what's the smallest unit that I'll write to your disk. And usually block sizes come in like 512 blocks or 512 bytes or something. And what that means is I will chop up your file system into certain blocks, and when you want to write data to the file system, you have to chop your data up into those blocks as well, right? For the most part. So if I have block sizes of like 512 bytes, but I want to write 513 bytes, right? One more byte, I need to use 2 blocks to contain that. So on disk, I'm really going to actually be using 1024 bytes to hold my 512 bytes of data, because that's the block sizes, right? I have to use at least a block for any amount of data inside of it. So does that make sense so far?
It does. I guess where I'm getting tripped up is volumes, because I know with Docker, volumes are sort of like a file system.
Yeah.
Or some. So that's where I get a little tripped up. Where, so I get the block size.
Yep.
So from the usage standpoint, what would be a good? Do you have an example of where those would be used? So, you have, like in your example, 513 bytes. Obviously, you'd probably use more in a real world scenario.
Right. Yeah.
What would you use it for?
Yeah. Just to store data, right? You were
Okay.
you were pretty spot on when you said like it's like a virtual hard drive, right? It's like access to some hard drive somewhere. That's kind of what it is under the hood. And it's just the reason why they call it block storage is because it's broken up into those blocks that you can access, right?
Mm,
So if you say, "Hey, I
got it.
want a 1 gigabyte block device," something somewhere will be like, "Oh, I have block sizes of 512 bytes. I'll give you 512 times whatever makes 1 gig. Here you go." And you can write data here. And the use case of block storage volumes, and honestly, to be completely honest with you, the terminology here is garbage. The industry is really bad at naming things. And I think the term block storage volume, this, that, file system, whatever, is too like arbitrary, right? But generally what it means is this is where you can store your data. It's like a piece of hard drive for you to store your data in. And it's usually persistent, meaning that like if your VM goes away, the block storage still stays around and you can just reattach it to another VM later on. So it's a good way to
Got
store
it.
persistent
Okay.
data.
Okay. So they you can attach these volumes to VMs and
Yeah.
other things. Okay. Cool. Sounds good.
And
Thanks.
then object storage is not some block device that you can attach to a VM. Instead, it's some like almost API endpoint that you can send it sort of like requests to read and write data, and it reads and writes that data
hmm
to some other device somewhere that it's in control of. So you
So that would
say, go ahead.
so that would be like S3. Would that be an
Correct.
example? That's
Yep.
an example of object storage. Yep. Okay.
Exactly. You don't
Or
to work with
R3 or
S3.
R2.
Yep, to Cloudflare R2, Backblaze B3, S3, all of that stuff, right? Backblaze B3, B2, I forget what it is. But yes, that's those are examples of object storage. And you don't interact with object storage by saying I want to write like a file like a hard drive. You say, "Hey, I want to write this file or object," and you kind of make an API call to do that. So it's just a different way of accessing the files. And there's no real concept of like a file system. There's no real concept of like a directory structure. Everything in an object store is like an object ID, like usually in like in a path form, like a URL path.
Got it.
And there's also file stores too, which are different from block stores, which is fun.
Yeah. Yeah, like I said, the terminology here is very, very frustrating. Very, very frustrating. Oh, and someone brought up Docker. But yeah, you can use Docker volumes. And that really is just a block storage under the hood, usually provided by your system. Like if I don't even know what I have here. Sure, right here. So like if I have this, if I want to run this Nginx pod, oh, I don't have this. I'll just run, sure. Okay, I already gave it a name. See, Nginx testing. Oh, you bastards, man. I know that relabeling is not allowed. What do I have in my directory? Can I just put temp in there? Jeez. Sorry, I wanted to show you the thing of the thing. Okay, I'm not gonna relabel you then.
The reason why it's relevant to have like block stores and whatnot in cloud instances is because you can't be guaranteed the next time you spin up your server that it will be the same server you're on, because you
Correct.
don't know where you're actually running.
So like in this case, I started an Nginx container and I said, "Hey man, mount my /temp on my host into the container at user share Nginx HTML as a volume." So what happens here is they're going to create a volume. So podman inspect Nginx testing. So there will be a bind mount. So this is basically saying, "Hey host, take your temp and put it here in the container as read write and all these other options." And then if I were to like exec into this container, Nginx testing bin bash, and I looked at, what was it? User share Nginx HTML. In here would be my stuff. I'm getting permission denied because I have SE Linux running on my machine and it's denying me, which is what I was saying before. Like I couldn't relabel the stuff. If I disabled SE Linux, you would see like content in here from my host machine. So yeah, that's the whole idea. And we use volume mounts in containers so that as containers come and go and they're killed and whatever, the data that they're storing is persistent. That's really the only reason why we use volumes, so that storage, like state, is separated from runtime, you know?
Got it. And so these block storage volumes are the cloud version
Correct.
or
Yeah.
a
That's
way
the,
to store those volumes?
exactly. That's the cloud provider's way of saying, hey,
Uh,
I can give you storage too.
got it. Okay. That explanation makes a lot of sense. Okay, cool.
Yeah. And I'll show it to you in a second. Like a real example.
Another good distinction is block stores are for like one instance, whereas like a file store or an object store is meant to be shared between whatever wants to request the information.
Yes and no. Block storage can be mounted to multiple places sometimes. But generally, yes, it's attached to one place. It's just, yeah, it's weird.
Oh no, now I don't. I'll have to look into that. Oh no.
Yeah, you can like have a block storage device that's accessed by multiple like instances. But that's, you get more complex, especially in the case of Kubernetes and all this other crap. So, but you are correct.
If I
that
was
we
running,
usually use object store for that.
if I was running Postgres in a container and I wanted to have a volume that obviously was persistent past the life of the container,
Mm-hmm.
so storing that Postgres data, would I be able to, or these block storage volumes, um, if I wanted to store, I forget what the directory is. It's like var something. Could I take that volume and then store it on the cloud provider? And then whenever I spin up a new Postgres container, I can then bind that volume into that new container. Is that
Yeah, exactly. So like this, I'll just do one of these
okay?
real quick. I'm just taking this from the docs Postgres password. I'll just call this Oxide because it's in my head. PG data, custom mount. So let's say I wanted to custom mount, I don't know, mount PG data from my host to this location. Hopefully SE Linux doesn't kill me, or I'll just disable it. Actually, I'm going to do a local mount. So I'm going to do make directory temp PG data. Something that I have ownership of. So I don't have to like, because Podman is meant to run as like rootless, and I don't want to get into the weeds of that crap. Okay, Podman logs some Postgres. Ah, yeah, that I'm gonna get caught up with this crap, ain't I? Because this can't actually relabel the stuff. Damn it! This is why I'm getting sick of Podman. Because when you want to run the simple examples, you have to like freaking. Oh, you always have to like run into the bull crap. Hold on, let me see if I can fix this real quick for you. Some Postgres. I wonder if this will let me run. Yeah, that'll work. Okay, yeah, Podman logs some Postgres. So you can see Postgres is running. It's here. Everyone's happy. It now, like if I were to exec into here, so Podman exec it some Postgres bin bash. If I go in here, you'll see at var lib Postgres data, this is where the PG data. This is where all the Postgres data is in the container, right? If I get out of the container and I look at temp PG data, sudo, it's here too on my machine. So I've bind mounted this. So this path on my machine is mounted to this path in the container. So even if I were to like remove this container from life, if I were to create a new container in its place pointing to the same data, we're all good. Because that data persisted.
Got it. And you would store and this volume, I guess, in the temp directory in the cloud somewhere if you wanted to.
Yeah, you would have some backup
Yeah.
strategy so that like it didn't just
Right.
die, you know.
Cool. Yeah.
Yeah, so that's what you would do. Like, and if I went in here and I did psql-u postgres, like oh, I guess I can't do that. Oh, let me just go in here real quick. Cool. Now I'm in the database, right? I can like create database foo. I've created a database. If I list databases, you'll see a foo database there. And now if I like quit out of this container and podman rm-f some postgres, I'm gonna remove this container, right? So now podman ps-a. Oh, actually I can remove all this other crap. Sorry, one sec. Let me just remove this other crap that is not needed anymore. Like my Rust server. Goodbye, Rust server. So now I have no containers at all, right? Nothing here is running, but I still have that PG data, right? If I ls that location, it's still here on my host. So I didn't lose the data, but the container is gone. So now if I were to like rerun that container, which I think was this one, if I rerun this and now I look at the containers and it's running and I go back into this new container now and I do psql-u postgres and I do -l, that foo database is still there because it was able to say, hey, you had data here before. I'm going to use that data. So that's the purpose of using volumes.
Great. Thanks.
If you were to back up a database, like what I have done, which is probably, I mean, could be the right thing, could not be, but you can export the database and more or less like run your SQL files to create the new SQL database versus mounting. Is there like a reason you'd use one over the other?
Preference, honestly, and you're totally correct. If I were operating, like if this was my production database and I was operating this, I could, one of my like data recovery backup strategies could be, oh, take this temp PG data location and always back it up somewhere, right? Like, so literally just like, copy this -r to like, temp backup, right? Some other location. And I can't do that because it's owned by root, but you get the idea. So this would be a backup strategy, right? Periodically copy the data somewhere else, like the physical data, right? Copy the physical volume somewhere else as my backup strategy. That way, if I had a disaster, I can recover. And in this example, obviously, like I'm using /temp, which is not a place you would put persistent data. I'm just using it as an example for this video or the stream. You can put this wherever you want. That's one way of backing up your data, like raw data backups. But Postgres and other databases have a way of backing up their contents from their app level. And we call that more of a logical backup, like Jacob was saying. You can set up Postgres to do logical backups or replication to some other location. You can do like streaming replication to replicate the data to some failover instance. You can do PG dump to do a dump of the database, and you get like a .sql file or whatever, and you can store that somewhere. There's many ways of doing data backup.
With the strategy I've done with Postgres, using PG dump and then saving that to S3 and then writing the write ahead logs also to S3 to do point in time recovery. Is there kind of a nice harmony that you've found with, backing up your database? Is it just that kind of strategy, or is it kind of a mix of copying volumes? What did you find as a nice flow
I
for that?
don't generally copy volumes for database backups. I usually use the database tooling. So like the PG dumps, the streaming replications, that nature. Back when I was working at CockroachDB, we would not back up the volumes pretty much ever. We would use Cockroach's native backup utility that knew how to back up to an object store location directly. So we would configure each Cockroach cluster to back up to its own S3 bucket somewhere. And that's how we would do backup and restores. So we would never actually care about the physical volume. In fact, sometimes if a node was like really beyond repair, we would just delete the volume and the node and let the node come back up fresh with no volume and replay its backup from other nodes. So again, it depends on what you're using. Postgres is not clustered like Cockroach is, so it's a different like paradigm. Any other questions around this? Oh, I can't type. Okay, I show some cloud stuff. Let me show some cloud stuff. Okay, so there are many. Hopefully this all works because I don't remember what I even have. I'm not on my work computer. Sorry, Oxide. I'm so sorry. I bad person. Let me open up 1Password because 1Password is my SSH agent. So I need that open. Okay, so let's show cloud. If you wanted to use cloud machines, right? You don't want to run virtual machines yourself. You don't have a server in your house, whatever it may be. You want to run cloud machines. So I'm going to show you Oxide because, disclaimer, I work there and I couldn't possibly show you DigitalOcean when I work at Oxide. Like that would be just sacrilegious. So I'm going to show you like what Oxide gives you. So in here in Oxide, I have access to basically compute, right? I have my own access to compute and I can spin up virtual machines on this big ass computer that we have in a data center somewhere. And the way I would do that is I'd go in here and the very first thing I would do is I would create an SSH key because I want to be able to connect to whatever server I'm going to connect to, right? We don't use password authentication to connect to servers over the internet because that's bad, right? It's very easy to do password cracking and blah, 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 blah. So you would use SSH keys because those are cryptographically secure. So first things first is generate an SSH key. And if you're not sure how to do that, you can do SSH keygen. And I always recommend doing ED25519 types because they're a stronger cryptographic algorithm. Once you have an SSH key though, you're going to load it into your panel here, which I've already done. There's two parts to an SSH key. There's a private key that you keep on your system. And then there's a public key that you upload to GitHub, to Amazon, to Oxide, to DigitalOcean, to wherever you want to create things. My private key is actually stored in 1Password because 1Password like dynamically gives it to my session as needed. So cool, I have an SSH key. Let's create a VM. I need an image to create a VM from. Now I have one image here called Talos Linux, but the whole server that I'm on for Oxide has more images that I can use, like Ubuntu and whatever. And if we were in AWS, then they have a bunch of images you can choose from too, right? Ubuntu, Debian, whatever. But what I want is I want a new VM. So I click New Instance. And this is going to say, hey, give me some information to create this instance. And I'll just call this like, Linux testing, right? This is a test instance. I get to pick my hardware. So I get to pick like how many CPUs and RAM do you want to give this thing? And I'll just keep it at the default. What image do you want to boot from? I'll boot from this Ubuntu 2404 server. So I'll boot from that. How big do you want its root disk to be? I'll just bump that to 50. Who cares? I don't need to give it a disk name. I don't need to attach additional disks. I'll show you that later. I need to tell it which SSH keys should be injected into the VM so that I can access it. And then from there, I need to say like, give me some networking. And I am going to give it a network interface and I'm going to allocate an IP for it out of my VPN pool. So all of this is to say, once this VM is up, so I'm going to hit create. Once this VM is started and booted, I should be able to connect to it based on the IP that it gave me. So I'm going to wait a second for it to create. Okay, so this is creating. This virtual machine is now starting. It's booting Ubuntu. I can go into the serial console, which is like the same thing if I were to connect like a monitor to this VM. If I were physically there and connected a monitor, this is what I would see. So I can see the physical terminal essentially. So this VM is booting. Now, when it finishes booting, you'll see that it's going to present me with a prompt. So here, Ubuntu is booted. It's going to say, hey man, can you log in? I can try to log in here with Ubuntu, but I don't have a password, right? Like I've never set a password. Generally in cloud systems, you don't ever use password authentication. In fact, the images that are provided by the cloud systems often don't even have password authentication enabled by default. You have to go out of your way to enable it. So I can't actually log in here because I don't have the password. But what I do have is an SSH key. So I will get out of this instance thing. I will take this IP address here, and I will now connect to this via the IP address. So I'll do SSH. I have to SSH as the root, the Ubuntu user, and I'll give it that IP address that's on the VPN that I'm on. And it's gonna say, hey, you want to connect? Yes, I do. It's gonna open up my 1Password to prompt me for the SSH key, and then boom, I'm in. Now I'm on this Ubuntu machine, and I can do like whatever I need to do, right? I can do cat etcos release to show you that this is Ubuntu. I can, sudo apt-get update to like do some updates and upgrades. But now I have myself a virtual private server or a VPS running. Questions so far?
Not so much with the process, but with Oxide in particular, for let's say more hackers, indie people, people who just have side projects. Is that what Oxide offers? I saw what you selected was 8 GB of RAM, 2 virtual CPUs. Um, are we able to potentially get our hands on one of these VPSs to use, or is it more for enterprise customers
More for
for
enterprise.
Oxide?
If you do work for a company that's like looking to, move off the cloud and get more on-prem compute, you can go to oxide.computer and like do a try it now, and you can request access to a silo that we're running on this same rack that I'm connected to, and you can get one. Generally speaking, we're doing this for prospects that are interested in buying an Oxide rack, but we don't have any cloud services or anything that you can access yourself as an end user.
Got it. I was just curious. Cool.
Yeah. So we have a big ass rack sitting in a colo somewhere, and I have access to the full rack. So I can like deploy as many VMs or whatever as I want. And these things it's a beast, right? There's like 2048 cores, 32 terabytes of RAM. There's a shit ton of hardware in this thing. But once you buy this thing and you install it in your own data center, then you get access to the same UI that I'm showing you, and you can like run all your VMs to your heart's content. Okay, so now that I have this VM, we talked about disks before, right? So Oxide also has a concept of block storage. So we have a concept of disks, block storage. I can create a new disk, and I'll make it a 20 gig disk, or maybe I'll make it a, let me just give it a name. So I'll do it Linux testing disk. It's gonna be a blank disk. Here's that block size I was talking about, right? Block storages have block sizes. So if you click one of these, you're saying, hey, I want to store 512, block size is 2048, 4096. So that I was talking about that. And I'll make the size 10 gigabytes is fine. So that disk is now being created on Oxide, and now it's there. So I've just created some block storage, but I did not attach it anywhere. And I'll attach it in a second. But I want to show you back on the VM, if I do lsblk, that stands for list block devices. And if you remember, when I created this virtual machine, I created it with 50 gigs of a OS disk, right? A boot disk. And you can see that here, 50 gigs. Now, if I were to attach this, so if I were to like go back here, and I think I can attach it from here or attach it, I forget where I can attach it from. I always do this with Terraform, so I forget like how to do it in the UI. So I think I can do attach. Okay, I have to stop the VM first. So let me do that. Stop the VM. So wait for that to stop. All right, now that the VM is stopped, I can attach a disk to it. So I'm going to attach that Linux testing disk to the VM, hit attach, turn it back on. Let that go up. Oh, and now I killed my SSH thing. What's the keybind for the SSH hang thing? Escape tilde, no, escape tilde dot, enter tilde dot, no, enter tilde dot. Yeah, okay, there you go. I forgot the command to clear the hang SSH terminal. Cool. So now I SSH back into the VM that I just attached a disk to, and I do lsblk again, and you'll notice not only do I have that 50 gig disk, but now I have that 10 gig disk attached to it. And here, now I can do things like partition that disk, put a file system on it, mount it somewhere, and then start using it. So that should hopefully like start solidifying the concepts in your head a little bit more. Any questions so far? I'm just looking at all of you in chat, just there, just staring at you. Okay. That's cloud systems. I mean, if there's any other questions, I'm happy to talk about it, but that's the idea of cloud systems. AWS, GCP, Azure, all these places, they provide you essentially that, right? You have some place that you can go to spin up infrastructure, and then you can connect to that infrastructure and like install your apps there and blah 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 blah. That's cloud systems. And the one thing that I'll probably end on for cloud systems before we go to the next chapter is remember when you're using cloud systems, you don't own anything, right? You don't own the machine, you don't own the network, you don't own anything. You're always renting. So costs for cloud system usually get exorbitant, right? They're very expensive very quickly. Because they charge you for like almost everything, right? They charge you for compute time that you're running instances for. They charge you for any sort of storage used. They charge you for any sort of network bandwidth used, all of that stuff. So it can get very, very expensive very quickly. That's why we're starting to see a lot of people in the industry migrate back to on-premises computing. So that's where something like Oxide makes sense. Cool. Anything before we go?
Of like trust there. Oh
no, go ahead, go for it.
Oh, on the note of trust again, this is another thing where we're just like, it's their computer, so if they so chose, they could like go dump your database or do something else with it, right? Like
For cloud providers, like if I spin up an instance in
Mhm.
AWS or something.
Yeah, like if AWS so chose to like violate their customers' trust, they could, right? Like
100%.
there's
Yeah.
also nothing stopping them there.
There's nothing stopping some rogue person at Amazon from like going into their data center and like pouring water on a rack that's running your VM. Now, from the data trust perspective, technically speaking, yes, it is possible for some AWS employee to access your data on your machine, technically speaking. However, modern cloud services have a level of like encryption where either they control the keys or you control the keys. And if you control the keys, then they can't access your data because it's encrypted. Like they can access the raw encrypted data, but they can't access the actual clear text data. So yes and no, right? There's a level of trust there, but also yes, some rogue person could do something if they really wanted to, assuming that you use their encryption keys. Any questions, or should we go to the next section? My friends are making fun of me in the Discord. Cool. All right, let's move to what, chapter 10, Jacob? That's where we're going next.
Yep, we have logging.
All right, cool. Let me just destroy this
Whatever
VM.
that happens to be.
Let me just destroy this real quick, because if not, I'll forget about it, and then I'll go to work tomorrow and be like, what the hell did I do here? What is this thing? So let me just destroy
create
all
a
this.
32 terabyte one. And
I mean, I
Oh,
could.
yeah,
We're
but-
barely scratching the usage on this thing, so I could technically just create whatever I want. And in fact, we're encouraged to run our personal workloads on the Oxide rack. Like that's what our leadership said. They're like, please do, go for it. Let us know what's broken. So I'm gonna move a lot of my stuff here. Anyway, cool. Chapter 10, I think. Was it the whole chapter or where? I don't remember what we read here.
Let's find out. Logging, I believe, was most of the chapter, if not all. We have log locations, files not to manage, how to view logs, systemd journal, configuring systemd, adding more filtering options for system or for journal control, coexisting with syslog, kernel and boot time logging, management and rotation of files, log rotate, and that was it.
Oh, good. Okay, so basically just log location, system journal, and management. Awesome. All right. Any questions in logging?
I had a question on the table. There's table 10.1. I actually wrote down which table it was so we could find it.
Yes, that's what I'm talking about. This table?
Yeah, 10.1. Yeah, I was wondering why exactly they labeled all of these with different OSs. Because, like, for example, they put, I think HTTPD, yeah, HTTPD is in there, and they mark the systems as Debian, or does that say R? Oh no, it says R. Oh, okay. Well, yeah, I was just wondering why there's certain systems that are like, do these servers just run on these systems or what?
Systems can be D for Debian or R for Red Hat and F for BBSD. Okay, yeah, I see. Logs on Parade, log files on Parade. I think it's because HTTPD is how, like, the log file on Red Hat is HTTPD directory, but on Debian it's Apache 2. And on FreeBSD I have
Oh,
not
I didn't
a
even
clue.
see that.
Yeah. FreeBSD, I have no
okay.
idea
Yeah,
where
I just
that
didn't read
source.
those there. I was just like, huh. I was thinking they were saying HTTPD can only be ran on Red Hat or only Debian, and I was like,
Oh no. This
but
is
I
just
only read
saying
one or
like,
the other.
yeah, this is just saying that there are various different standardized locations for different log files on different OSs. And even if you're using the same program, like HTTPD in this case, it could store its logs on different locations on different OSs. This is where like distributions, this is where distributions of like Linux distributions separate more, right? Like generally speaking, all Linux distributions run the pretty much the same exact kernel under the hood, right? The Linux kernel. But they have different package managers of how to install software. They also have different conventions for where they put files, like you're seeing here. Log files can be in different locations depending on the distro. I kind of hate it, I'm not gonna lie. That's why you'll see people that are like, oh, I prefer Debian, the Debian's distros, because they're used to that like convention. Or some people like, I prefer Enterprise Linux, Red Hat stuff, because they're used to those conventions. And this, you're seeing it on display here, like where it matters. Trying to see if there's anything else that is the same, right? Like, yeah, D package is for Debian, so that's there. Yum is for Red Hat, so that's there. Secure is for SSH. Trying to see if there's anything else that's like different across. I don't see anything.
The kernels. Check kernel ones. They're kern.log and dmessage.
Oh yeah, that's a good one. Kern.log, it doesn't exist on Red Hat if I remember. Yeah, that makes sense. But dmessage does. So yeah, that's all this is saying. Any other questions on logs?
I have a question on page 300. It's sort of related to logs, but not really. It's the here doc syntax always trips me up.
Mm-hmm.
Would you be able to walk through kind of like how I should read this? Because it always trips me up.
Yeah, no problem.
Because I see it a lot.
That's a good question. So the here doc is pretty. It's actually pretty simple. So all this is saying is we're going to cat something out, right? What are we going to cat out? We're going to cat out the things between this end location. So things that we're going to cat out text until we reach this end token, right? Where we're going to put the stuff once we found it, we're going to put it in this file. So you can read this to say, take these 2 lines and put it in this Etsy systemd journal whatever file. Why these 2 lines? It's because these 2 lines are the only lines that appear before this end marker. That's it. And you can make this marker anything you want. You could have called this like foo. It just has to be some marker that when cat sees it, it stops.
And is that the only accepted or idiomatic way to write here, Doc? Or is there other ways you might see in the wild?
It is dependent on your shell.
Okay.
And also dependent on the program that you're using. Did I just use Google? Oh, I just used Google search. If you're like a Terraform user, they have their own version of HereDoc strings where they do a similar thing, right? Like, here's a token start, token stop, but then they have different flavors of like whether or not there's a hyphen for indented HereDocs or not, because if you want to indent something, like you need to account for that and blah blah blah. So whatever program you're using, just consult its docs. But for Bash, which is the shell that this book is covering, this is pretty much the accepted syntax.
Cool. Thanks.
Yeah, you're welcome. I think a lot of people get tripped up over like this greater than whatever. That's just the redirection.
Yeah.
Like that's all that is.
Yeah, I always got tripped up with the end because the 2 redirections, confusing, but that made a lot of sense.
I can close that. Yeah, I can show you real quick too. Like cat. Oh, I'm on fish. Let me go to Bash. Cat foo, and then I'll put this in like temp foo, and then hello there person, and then that would go to that. I hit Control C like an idiot. I meant to hit Control D to tell it was done, but the idea is that like I'll just do it again, and then I'll put foo, and boom. Now what's going to be in this file, cat temp foo, is hello there person, because that's what was in between the marker, and that's it.
Got it.
Very, very useful for like things that need to be exactly how they are, right? So if I had like some YAML file like this, if I had some YAML file saying like foo equals bar, and then like some nested key like bar equals baz or whatever, and then put foo to end it. Now if I cat temp foo, you'll see that it can maintain that structure, right? The spaces are there and everything's happy. Very useful for like that type of data.
I see these in usage, like documentation strings, like the help strings for command line.
Yeah, that's a good example of where to use it. It's like line everything up correctly. It's really nice. And if you're like, whatever your favorite programming language is, it probably has a string literal syntax that's similar to like the HereDoc syntax, like same concept.
Gotcha.
Any more questions on logs?
A probably pretty obvious thing, and I feel like I'm 95% sure, but I was wondering why log aren't persisted for longer typically. Is it just expensive to have the storage, expensive to index it, search through, or what?
Yeah, generally logs on the system aren't indexed. They're just stored in files, and then those files are rotated periodically. So like on my machine, let me go back to fish. So on my machine, I have ls var log. There's a bunch of log files in my var log directory, and all of these different directories inside are for different services, right? Like AK mods is for like dynamic kernel modules that I have. Anaconda's for my the installation program, and blah 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 blah. Cups is for printing. Boot log is self-explanatory. DNF log is for my package manager, and so on and so forth, right? All these different logs. So you'll notice that they are like rotated periodically, right? They don't go on forever, because you would eat up your disk and can crash the system, right? So that's one reason why we don't keep logs forever, because we will crash our system. You could send these logs to some other like third-party service somewhere, like Datadog or Axiom or whatever, and you can send your logs there, and they'll keep your logs and aggregate them. But on your system, they're generally not aggregated. They're just stored in flat files.
So then on the note of the aggregators, why not, like, same question applies, like those would typically be indexed in some way, right?
Yeah, because the point of an aggregator is to like efficiently search logs, and you can't efficiently search something unless you like index it correctly.
So then is it similar reasons to what I'm suspecting? So like it takes up storage, and like it's wasteful potentially for not using logs that are like a year old, and then indexing will be tougher. Like the indexes will also grow with the size of the whole data set.
Not necessarily. Generally, the indexes are based on time. Like, if I send logs to like Axiom today, they will index it and store it. And then if I send them new logs, they'll index it and store it. But if I want to query for like a year's worth of logs, they're not searching just one index. They're searching for multiple indexes based on the time, right? Like maybe they have an index that accounts for the last 24 hours of logs, and that's one index. And then the next day of logs is another index, and so on and so forth. They have their own like ways of indexing it smarter for their use cases. But yeah, I mean, it is wasteful at the end if you're not doing it efficiently, right? That's the whole point. Like Datadog, Axiom, all these companies that store your logs for searching, they'd be out of business if they did it pretty inefficiently, because they would store so much data and they'd have to look through so much data. They would be out of business if they didn't do it properly.
Yeah, I guess that's just generally my question, because I've seen like I've had logs that are only persisted for 2 weeks and would have been great if they existed for longer.
Yeah.
And I know it's more expensive for that, but yeah, must just have something to do with the cost on the end.
Yeah. I mean, in the case of Datadog, they're kind of dicks about this stuff. You know, they just charge an exorbitant amount of money. So, you know, for them, it's like, you want to store your logs 1 second longer? Give me $500,000. I'm exaggerating, of course, but that's kind of the idea. Other systems are a little better with it. Generally, the way people do this is they use like a tiering approach, right? Where the last 24 hours of logs are stored in like hot storage that's indexed and ready to rock for queries, and then like the next 30 days of logs is stored in like a warm tier storage that's kind of indexed but a little slower to query, and then anything 30 days or older is just stored in like Amazon S3 or something, because it's cheap but it's very slow to query in comparison. And that way, as data becomes older, it becomes less expensive to store it, because you kind of move it off the hot tier into like some colder tier of storage. That's generally how people do it. So in your case, like those 2-week logs, you can have them in Datadog or whatever, but then after 2 weeks, you can send them to somewhere else so that you have them, but it might be a little harder to query them.
Yeah, it makes sense.
Okay. Any other
Some
questions?
more historical questions. They mention Syslog will eventually become less relevant here. So how relevant is Syslog today?
That's a good question. I think that depends on who you ask. Like Syslog is still a thing and people still use it. But like with the advent of System D, so this is actually a tough question sometimes to answer. Back in the day, if you wanted to get logs off your machine, you had to use Syslog, right? Syslog was a way of like routing logs to different files, and also a way to like send logs to remote locations with our Syslog. And that's how you would send your logs across. And there's a protocol or format to follow, whatever. Systemd came along and was like, oh, I'll manage your logs for you, right? So what Systemd does is it manages the logs for all of the services that it runs, right? Remember how we spoke last week or the week before about how Systemd basically runs all the services on your system. And since it runs all the services, it has access to the services standard output and standard error output, right? It collects those and stores them in log files, and then it can present them to you by commands. Nowadays, though, there are pieces of software out there that are responsible for like sending logs to other locations, right? So like if my Fedora machine right now were some important server somewhere, I could use journal.ctl to get logs, right? I can see logs. Great. Everyone's happy. I can see logs. I can see logs for a service. So like SSHD. Here are the logs for my SSHD service. This sucks, right? If I had to like look through these logs to figure out a problem, this is very painful. It sucks. It's hard. Instead, what I would do is I would use like some program to send these logs to some external service. Now, you could use our Syslog to do that, depending on if your service supports our Syslog, or there are many other services out there, like, also I'm going to go to google.com because FluentBit. So FluentBit is one such service. It's a way to like read logs and send them off. Open Telemetry is another one. Also, sponsored ads. What is this? People use this search engine? Ugh. It's hurting me. Open Telemetry is another way. I do have the ad blocker running, but I'm browsing. Like I created a profile real quick just so I can connect to my Oxide stuff. I can just close this because I don't need to do that anymore. And we'll use the better search engine. Ah, yes, much better. Okay. There we go. FluentBit, OpenTelemetry, these are like tools you can use. Vector, I don't know if anyone's heard of vector.dev, I think. Yeah, Vector, that Datadog ruined. Purchased. But there's all these different tools out there that allow you to read logs from your machine or read telemetry data from your machine and like put it somewhere else. Send it to Datadog, send it to Axiom, send it to God knows where. So if I were to treat my Fedora machine as like some critical machine, I'd probably just run one of those services and send the log somewhere else. And I would never use Systemd or journald or any of this stuff to read the logs ever again. That's what I would do. So to answer your question, Syslog dead.
On that note, it mentioned that potentially also in the future there'll be some software that comes with Linux distributions to send off those logs and whatnot.
They mentioned that.
Yeah, they mention it, and like now, or as of 2017, you would need to install certain software to then sync it somewhere else.
Where do they say that? I want to see what they said. I just want to see what the author was like saying when he said that.
They mentioned like stream as like a keyword around it.
Yeah. Probably like, I don't know where it is. It's fine. Generally speaking, machines don't actually come with a service for shipping logs around. I mean, you could use our syslog, that's probably on the machine, but you probably wouldn't use that in like modern times. You'd probably just install something like FluentBit or whatever and be done with it. So okay. I don't know what the author was trying to say there, but yeah, if I were doing something, I'd be like, give me FluentBit or give me OpenTelemetry, and I'll just do that to send my data around. Also, logs are becoming a little less relevant in a sense you were mentioning this the other day in the Discord about tracing. People are generally moving toward this concept of like distributed tracing, which is like your app is emitting some sort of structured telemetry data. It almost looks like a log. It looks like a structured log, but it's a trace about what your app is doing. And that trace can be viewed as a nice like waterfall graph of how all the function calls link to one another. That's generally the paradigm most like mature software teams are going. And then they're sending those traces to some location to do aggregation and querying. So your mileage will vary depending on what company you're at and how much into the 2000s they are. You know, are they in 2006 or are they 2016 or are they in 2025 now? You know. Any other logging questions?
They mentioned a few different log stacks in here, and I was wondering if you have a favorite. I mean, I guess I didn't really think of log stacks as anything originally, but like, do you have a favorite way to aggregate observability information in general to make it wider than logging?
What do you mean log stacks?
They say log stacks, and they mention like
Oh, like elk?
Elasticsearch. That.
Oh, yeah,
I didn't really think of that as a I haven't thought of it as a concept too much.
I want to see where the management of logs at scale. There we go.
I guess that's a good question too. Like, is that relevant to do, or do people typically just go with like software as a service? Because I don't think I've seen anything.
If I were doing this today, so I've used the elk stack before, right? Which is Elasticsearch, Logstash, and Kibana. That's what it stands for. Elasticsearch is like the storage engine. Logstash is the log like forwarder and receiver, and Kibana is like the UI viewer component of that. I've used it before. It works fine. Graylog is, I think, a SaaS that deploys elk under the hood for you, and you can just like send your data to it. I've used both of these before. I'm not trying to shill any company or anything. I'm not getting paid for any of this crap. All right, this is not a sponsored stream or any of that, right? So I'll do the whole disclaimer. But if I were sending logs around today, I'm not gonna lie to you, I'm sending it to Axiom all day. Like, they're cheap as hell. They have a fantastic query language, and they support all of like the modern formats for data, you know, like OpenTelemetry format or just raw JSON format for logs. They support all that crap. So I would send my logs here if I were doing like log aggregation at scale. That's what I would do. You could alternatively deploy
really free tier.
Oh, their free tier is amazing. You can deploy Loki, Grafana. You can deploy Loki, which is Grafana Labs' log thingy. You could deploy this on your own like server somewhere in your house or whatever, and you can send your logs here. But to be honest with you, I don't like its query interface. It's a little frustrating to use. And with Axiom being so cheap, I would just use Axiom and not have to ever worry about anything. But that's my 2 cents. I would not reach for elk. I would not reach for Graylog. I would definitely not reach for Splunk or any of that stuff. I'd be going to Axiom if I were doing it today. In fact, I do send some data to Axiom today. I'm not signed in here, but I do send some data today. Oh, I can get rid of.
Yeah, good to know. I guess I've used Axiom and enjoyed it, but yeah, good to know that this is like also. I didn't think about like tracing not being mentioned at all in here.
Yeah, I mean, this is more of a Linux focused book, and Linux's primary telemetry data is logs, right? Like, your Linux machine doesn't emit traces, right? It emits logs. But if you're an application developer, which pretty much everyone here in this Discord is, you're going to probably emit some sort of trace from your applications, and you're going to send them somewhere.
Yeah, they're more separated. Like, if you want to see what the system's doing, like memory wise and whatnot, you can look at that, but it's separate.
And if you wanted to like go all in on tracing, then I would suggest like Honeycomb. They're very good at tracing sort of data. So I would suggest them too. They have a really good free tier too. I think it's like 20 something million events per month, right? Yeah, 20 million events per month. So that's a good free tier. And they don't like let you get billed if you go over it, right? They like just stop processing your data. So that's good for those who don't want to pay money. Okay. Any other log questions? I think we covered the gist of it, right? I think we got it, right? Logs are at var log. You can use journald to read them. Systemd manages that. You can use syslog, rsyslog to send logs around, but you probably want to use a more modern tool now. Logs can be rotated, usually with a thing called log rotate, and that just like monitors the log files and rotates them when they get to a certain size or a certain quantity or both. And yeah, that's basically it for logging, right? Unless you all have any
Yeah,
questions.
I think it was cool just to look into it. Otherwise, just like a comment, because I looked into some log rotate stuff that I'd seen before again, and it's like, oh, okay, that makes sense. Pretty intuitive. Cool.
Yeah, I mean, log rotation is a hard problem, right? Because you got to remember that there is a file like what's that? What's the good drawing thing? Is it TL draw? Do I have stuff to here? I do
Yeah.
have things here. Didn't we do this last time? Oh no, this was me on my stream. How can I clear the whole board? Did anyone know? I don't even know. Edit. Okay, we'll just do this.
You could probably
Whee!
like Control A, delete.
Wee. This is more
I
fun,
don't know.
Jacob. This is now I get to do this.
Okay, okay.
Wee.
There has to be some. You could probably just open another page.
Probably
That's
could
probably
just
what
do
you're supposed
this.
to do.
There we go. I'm a smart person, I guess.
Okay, I'm opening TL draw and figuring it out.
So you have like let's say you have like a foo service, or I'll stop using foo because people get mad at me when I use foo. Let's say you have an Nginx service, right? And this Nginx service is like writing logs to Nginx dot log, right? So it's writing logs, and at some point this gets like, uh-oh, we're full right here because this is like 1 gig of logs, right? We're full here. What do we do? Well, some log rotate program will come in and it'll say, hey, I'm going to take this Nginx log. I'm going to copy it to Nginx log, dot 1, right? Or whatever it's going to call it. And then it's going to, and then I'll call this like log rotate. This is LR for log rotate. So it's going to say, hey, like, let me put some logs here. Let me send a signal to Nginx. Usually it's going to be a sig hup or something, sig hup or something of that nature. And then now the logs are here. And what's going to happen is it's going to tell Nginx, oh, you were writing your logs last here in this file. Please reload your nginx.log and start writing again from the top. So what's going to happen is it's going to like erase these and it'll start writing from the top and do more logs. That's how log rotation works. And it's kind of hard, right? Because at some point Nginx was writing to a file called nginx.log, and maybe this file is like file descriptor 72, right? And at some point this file descriptor, you're at position, I don't know, let's call this position 107 in the file, right? Because every file has an offset of where you can write to it, and you're at position 107. You need to like stop writing here, move the file over correctly, and then tell Nginx, hey, you're no longer writing at file descriptor 72 position 107. You're now writing at file descriptor 72 position 0. Start again and re-go. So like it's kind of a hard problem to do log rotation correctly without losing data, but log rotate does it pretty decently. And the application like Nginx has to support, consistency when it's being sent whatever signal to like reload its logging stuff. So it kind of does turn into a complex problem, but nowadays it's solved for you. Moonpie Dumplings says they are looking into current logging solutions. Right now, OpenObserve seems to be the most promising thing for me, for my use case of Linux. I never heard of OpenObserve. OpenObserve.
Oh, okay, I looked it up to make sure I was right, and the way log rotate
Oh,
was
very cool.
configured in the example that I looked at does not send a signal to stop the server. It truncates the original file in place while it's running.
Oh yeah, that's another way of doing it, because the log rotation could monitor this file as well, and then just do a trunk and then let the seek location go back to the top. I think that's probably the more popular way of doing it, actually, now that I think. I'd have to, it's been a while since I looked at the details of log rotate, so I'm kind of just going from vague memory here, but I encourage people to look at it. Talk to AI about it.
Yeah, another fun thing it did was, like, beyond splitting it, would, like, gzip the old logs.
Yeah, that's also another
And
thing it
stuff.
does, usually. And I guess I'll show you real quick. I don't know. I don't even know if I have anything here. Let's see. Log rotate. Do I have anything here? Log rotate D. What do I have? Anything interesting here? I guess let's look at HTTPD. Or no, let's look at DNF, because that's something I use frequently. So you can see here, like, this is the log it's going to monitor, and it's going to rotate it after 4 entries or weekly. It'll create a new file. Like, these are all the options that it's going to do. I guess that's kind of a boring config. Wonder if there's anything that's nicer. Cronny? Yeah. After the rotate, like after it rotates the log by truncating it or whatever, it'll like call this command to tell Cronny, like, hey, cycle your logs, dude. So it has like a hook. So yeah, log rotate's pretty
What
powerful.
does or true do? Is the true some command?
This is just saying run this cronny command, pipe its standard out to dev null, pipe its standard error to standard out, which is also dev null. And regardless of whether or not this command exits with a 0 or a 1, if the command exits with a 0, don't do anything. But if it exits non-zero, run this true command. And true always returns 0, I think.
Okay.
I don't
Just
remember.
like how false is the opposite.
Yeah, true. Yeah, exactly. It's always returning 0. So it's just basically guaranteeing that no matter what happens, this post rotate command always returns success, even if it really wasn't a success under the hood. I don't know why they do this, but that's what they're doing.
So another question on log rotate.
Yeah.
I had seen it with a script that would run every so often. So like it would rotate or just like run every, let's say, 30 minutes. And then it would check to see if enough time had passed. And then if so, it would run log rotate. Are those configurations that were there considering, like, I don't think those configurations are make it run, right? Like it has to be run through some schedule somewhere else, right?
I think that I'm guessing, because I don't actually know the semantics of log rotate under the hood, but I would assume that log rotate knows which files it's monitoring, and it probably uses like, IO notify or something to check for changes in that file, or it probably periodically just looks at the size of that file to know if it's becoming larger or whatever. I don't know if it does that or if it just runs under, every like periodic time. No idea. I would imagine some combination of both though, because it's, it has to be smart. I was trying to see if
Google, it seems like you can run with some scheduler or run it manually. So there's probably somewhere else calling log rotate, and it just knows what's to do.
looks like there's a timer for it. So let's see.
Yeah, because I was wondering if it was just like, if that made sense, because what I looked at a bash script that ran in a loop forever, which seems odd to me in my mostly like application development brain, but maybe it just makes sense to run a separate process
Yeah.
to rotate logs like that.
So this says it runs every day. at a random, like not exactly at the same 24-hour mark. It like does some jitter, but every day it runs. But I have no idea if it also listens for, because there's a possibility that you say I want my log rotate to rotate after my file gets to 1 gig in size. That can happen in 5 minutes, right? If you have a noisy thing. So I think there's also some other mechanism in log rotate to say, watch this file and make sure it doesn't go above this size or whatever. But I don't know the internals of how it works.
Okay. Yeah, sounds good. I'll look into it a little bit more. I don't think it's like super relevant. I was just looking into it because I'm looking into like Nginx upgrade stuff.
Yeah, no problem. It's just a lot of these tools exist, so it's just a matter of knowing about them and taking some time to learn them,
Yeah, super glad that I know this stuff exists.
All right.
Well, like the shell redirection stuff has been great too.
Yeah, the shell redirection is amazing. I wish more people like just did basic proficiency with being at the shell, because a lot of people, especially when they come out of like boot camps and such, and they're like so focused on me front end developer, me get job, and then they only ever know using something like Railway or Fly or something to deploy their apps, and then they never ever had to use a terminal, and then they're just stuck when shit goes wrong, and then those same people wonder why they, aren't getting jobs and they're failing interviews, because you're not experienced yet, dude. People can see it. That's why. Nobody wants a developer that can't do anything when things go wrong, They want a developer that can both code and debug. But I digress. Let me not get my spicy takes going. Logs. Next chapter.
No more questions for me. Anyone else have questions?
No, I'm all set.
Okay. We are skipping chapter 11. We're not talking about drivers in the kernel. I don't think it's necessary as an administrator to know about drivers in the kernel. You can research that. Talk to AI about it. They're really good with it. Basically, like, there are different modules and drivers that the kernel can load. You should have an awareness of it, but nothing that we're going to cover because it's not like necessary, essentially. And we're skipping chapter 12, printing. I don't even think half you own a printer, but Linux can print too, I swear. And the primary way of it printing is called CUPS, which is, I think it's Common Unix Printer Service. Common Unix Printing System. Yep, same thing. But yeah, you can read about that if you want.
Let's do a poll. Who owns a printer here?
I own a printer, so that's 1.
I don't own a printer.
All right, so 1-1.
I do not.
Okay, 1-2. Dev Vertosa, you own a printer?
No, not really. No.
Wait, how is it not really? You either own a printer or you don't own a printer.
No,
you
no,
losing
no,
the
I don't.
printer?
How
How about stream chat? Does anyone own a printer in do you own a printer? Yes or no in stream chat? Am I the only one here that owns a printer?
Yes, I own the printer.
Oh,
Yeah.
2-3. Not bad. I mean, admittedly, I bought one for my wife's business, and it's actually now sitting in her business, but I guess I own it still.
I guess.
It works, right?
Is it like to set up printers for like Linux? Is it is it how it is compared to like Windows? You just have to like put in some drivers and everything, and just runs okay.
Yeah, you just open up your thing, unlock this, unlock your setting if you're doing it from the GUI. Go to add printer. Most modern printers now, like if they find one on the network, they'll like have generic drivers that get loaded. But if you do have to install a driver on Linux, good luck. Good luck. But most modern printers
My
just kind of
experience was not.
they work.
Mine did not work. I tried printing something from a printer from Ubuntu, and it said no. and then I had to go use someone else's Windows laptop.
Yeah.
I
You-
didn't
you-
debug too much because I had to like print something for like somewhere I was going.
Chat says that they don't have printers either, but that the experience of installing a printer on Linux is better depending on the printer you have. And usually modern printers are good. It was back in the day that it was really bad to install a printer on Linux. Now it's not bad.
I found
Is
a
it gonna
floppy
be?
disk for a driver for Windows 3 one time,
Nice.
like maybe 5 years ago. I don't know.
I do have a nice printer though, I guess. I have one of those like HP printers that like has refillable ink. Like you kind of put a bottle and you
Oh.
fill it in the printer. You don't take a cartridge out. Which is kind of nice. It works out, I
Oh,
guess.
that's cool.
Yeah, I have this thing. I show. I have like this printer where you get like the
Hello,
bottles.
Rich, we can't have a printer.
Oh, I didn't know having a printer was the new rich.
Have you seen how expensive printer ink cartridges are?
I have. Luckily, this has lasted us
Exactly.
for a while, so we haven't had to refill it yet.
I feel like if I want to get a printer, I have to do a bunch of research into it because I've seen so many of them that make you make accounts or lock you out if they have like DRM
HP's
on their
gotten
printer
bad.
cartridges.
HP's gotten bad with that. They have like a genuine printer cartridge with like some serial number on it, or it's really stupid. Chat is saying
You're
on
out with
Windows,
the printers too far.
yeah, I know. Chat is saying on Windows you sometimes have to install like some bloatware to install the printer, but Linux you kind of just like install it from the settings. And they said they remember hearing stories about how printer setup would be by one Linux server that has the drivers, and then expose that printer as a network printer for other machines to use. Which is true. Network printers are actually dope. It's not
For
a
the
bad
most
gig.
part, is it gonna be like distro independent?
For drivers? For printers?
Yeah.
I think so, right? I think drivers are what, like PostScript now? I don't even know, actually. I don't know much about that part of things. I guess it would just be like a generic driver across multiple machines. I mean, I think the OS side has to have a specific thing for its own like kernel driver, but outside of that, it's all going to speak to the same device running PostScript or something, whatever format. So I don't actually know the answer to that question. I guess it works like every other driver, and yes, it is OS dependent, but I really don't know. Anyway, we're supposed to be skipping this chapter. What are we doing? Let's get out of printing. Nobody has a printer
I'm gonna
anymore.
look more into printing later. I'm wondering why they're so tough, supposedly.
It's funny at Oxide, they spoke about this on the Oxide podcast. They had to create like the initial cryptographic keys for like signing our firmwares and such at Oxide, and they like bought like a dot matrix printer to do that because it was more, secure off the network, not phoning home to all companies. And they printed out the cryptographic keys and all that and stored them safely, and then destroyed the printer afterwards. So I thought that was funny.
Oh, according to Google, I will stop talking about printers after this. Sorry.
No, it's fine.
They mention on Windows you do not actually need to install the manufacturer driver. They just decide to give you bloatware if they want, and the actual driver that you need can be installed. Or, I mean, it's not exactly for your printer, but it'll typically work, and it is a few hundreds of kilobytes.
That's not bad. That's not bad at all. C Films says, "Hello, book club. Hello, C Films. Thank you for joining. I really appreciate it." I usually like promote the YouTube link instead of the Twitch link, but maybe I should promote the Twitch link. Also, I forgot that Twitch serves ads, and I keep forgetting about that. Damn it. Sorry for people getting ads. I'm just a poor streamer. I don't know what I'm gonna tell you. Okay, last chapter. This is the last book club, right? We're not going any further than this. We're stopping halfway through the book for now.
Yeah, this is the last for now, like for this run through of it, and
Okay.
we might get into more later. I'm interested in like I saw something about vhost that's referenced later, and I want to read more about that.
Oh yeah,
So
yeah.
I'm
I could
interested
talk a
in
little bit
past
about
running.
vhosts. But yeah, okay. So this is the last chapter of this book club, and then we're done with this specific book club because all we really wanted to do was read as much of the book as we possibly could in 1 month, right? That was the goal. So I don't think we're gonna go forward. But if there's other chapters that we like, if you're like, hey Matt, I want to talk more about storage or virtualization, we can Oh, I didn't even put a tag on Twitch. That's why, because I'm a bad streamer. Bad streamer is bad. My bad. Here, I got you. I always
I think
forget
it's
to
gone
put.
great otherwise. Oh, sorry, God.
No, I was saying I always forget to put tags on my streams because bad streamer is bad, and that's me.
Can't believe it.
Literally,
Yeah,
how do
I think
how do I even do that?
it's gone great for the 50% because like I have not finished every single one of these times. Like for TCIP, I did not finish, but that's good because I don't need to spend the extra time to get it all done because I finished like 75% of it, and then I can get the rest of it later if I feel like it.
Yeah, I think
Yeah, it's just
that's a
good to
good way
go
to
out
look
so
at it.
fast.
Even when I read this book in college, like the previous edition or whatever, we didn't go through the whole book either, right? You can't possibly. It's 1,000 pages. That's a lot to read, even in a semester, because you have to like talk about the stuff, and that's a lot. I mean, look at us. We like piecemeal read half the book in a month. Imagine doing this in like a semester of college. You'd have to read the whole book, and that's just a lot. So I think that's a good way to read this book is just pick out the chapters that are most relevant to you and like go through them. So speaking of this being our last chapter for this book club, questions on networking. I know we talked a little bit about networking earlier in the stream because that was like one of the first questions that came up, and we talked about the OSI 7-layer model and the TCP/IP 5-layer model. Any questions?
I have one. So on networks, you always have two of the host addresses that are reserved. I think for one for the gateway and one for the broadcast address.
Yeah.
Um, I am always confused by the use case for the broadcast address. Like, why is that? I know it's typically the last host, but what's the use for it? I know that the gateway, it just tells other hosts on that subnet, hey, if you want to get out, this is the IP address for the gateway.
Yeah.
But what's the use case for the broadcast?
Very, very, very good question. Now, I will bring up an IP subnet calculator real quick because I think it helps to show. And there's always one that I use. This one, Jody's. Yeah, this is the best one. So let's say I have this subnet, right? Most of us have this as our own home network. And we have this like 192.168.0.1 subnet, and it's a /24, which means it can have up to 254 addresses on it. You are correct that the first address in a subnet and the last address in a subnet are special. The first address, however, though, is not always for the gateway. Now, it depends on what you mean by first address, because technically the first address is 0.0 here, right? That is a real address. However, we usually don't use this address to assign it to like a client on the network. We usually just use that address as the network address to refer to the entire network. So that's why that's reserved. The last address that's reserved is the broadcast address, which is the 255, right? This one says if you send a packet to this address, it'll be broadcasted to everyone on the network. That's all that means.
And what's a use case for that? I yeah, because I'm always tripped up by when that would be used to notify every host on that subnet.
To do enumeration about services running. So like I think DHCP does this to get an address to start. It'll do a broadcast to say, hey, who's a DHP server? And someone will be like, I'm a DHP server. Here's your address. And that's how it communicates, because it has no idea where you are. You have nothing yet. So I think it uses that under the hood. As far as other use cases, I don't remember off the top of my head. Let's see what like
You mentioned
this says.
DHCP already, right?
Yeah, I mentioned DHCP. Is there any other common ones? Maybe ARP? No, ARP does its kind of its own thing. Yeah, I think DHCP is like the most major use case. I don't know. I don't remember other ones off the top of my head, so I'd have to research them.
What about
Gotcha.
like something like a Minecraft
ARP-
server? If
ARP's
you're doing
good.
that over LAN, you could send packets to everybody, say like, "Hey, this person walked over here." Don't know exactly how it works, but it sounds like
You wouldn't have
about
to
right.
do that. You could, but you wouldn't have to do that in that video game case, because you already know who you know what clients are connected to you. You know what I mean? Like in the video game case, you know, like I have 3 clients connected, so there's no point in broadcasting on the network. You can just unicast directly to them.
What about something like AirPlay or like
AirPlay,
casting to a TV?
I think it does use broadcast, but it also I think uses MDNS. I don't know off the top of my head what they actually use under the hood to do that. But you are correct. Like AirPlay or Google Chromecast or whatever it's called, I think they use this concept of broadcasting. I don't know if they use broadcasting directly or it's some other thing. What does AI say? Someone look it up on AI. I know DHP is one, but I don't know of other ones that I'm like confident
It
in saying.
says AirPlay uses Bonjour, which is multicast DNS, or
Yeah, there you
device
go.
discovery, which is a broadcast mechanism but not broadcast.
Gotcha.
But it did say multicast was just specialized broadcast, right?
Yeah, broadcast is send this to every device on this network. Multicast is send it to these multiple devices. Not necessarily every device, but multiple devices, more than one.
Okay.
To answer your other question though about the gateway, so you mentioned that like the first address is for the gateway. It's not for the gateway. The first address is the network address, and I want to just reiterate that. Technically, this .1 address is the second address. Technically, it's just the first usable address. Generally speaking, people do put the network gateway as the first usable address on the subnet generally, but you don't have to. I could have put the gateway as like .99 here, and that would have been fine. You know, so just keep that in mind.
Gotcha.
It's not guaranteed to be the first usable address, the gateway.
Got it.
Okay, more networking questions. Talk to me. I don't even remember what sections we read in this, so just hit me with networking questions.
We read literally everything.
Perfect.
Except for like the FreeBSD section.
Yeah, we were ignoring FreeBSD, not because it's bad, but because most people aren't using FreeBSD. They're using Linux. Yeah, hit me with some questions then to end it out.
I've got one more. It's on page.
Go
Oh,
ahead.
you can go ahead, Jacob.
No, go ahead.
Oh, the one question I had was on page
Oh shit, my dog
394.
scared the shit out of me. Sorry, I like jumped scared because she like was right next to me.
On page 394, paragraph 4, let's see. Yeah. Yeah, this concept of tunnels, where NAT implementations let you pre-configure externally visible tunnels that connect to specific internal hosts and ports.
You said 394? My
What
bad.
is it? Yes.
Okay.
Paragraph 4.
Am I seeing the right thing here? Is this it?
Yes. Yes, that.
Oh yeah, okay.
Just the concept of tunnels, because I know that you can have you can build a circuit, across the country if you have enough money, like
Yeah.
a dedicated circuit. But
Right.
obviously, if you don't want to do that, you can use tunnels. But I just get tripped up by the concept of tunnels in general on a network. So I don't know. It's kind of a broad question,
No,
but
it's yeah, it's a good question. That's a good question. Let me see if I can answer it off the top of my head. Let me read this paragraph. One issue raised by NAT is that an arbitrary host on the internet cannot initiate connections to your site's internal machines. Correct. To get around this limitation, NAT implementations let you pre-configure externally visible tunnels that connect to explicit hosts and ports. Okay, so it's basically like your internal service sets up a tunnel, which is exposed on like some NAT address, right? Some address that's natted, and then now external users can like see that as a tunnel and say, hey, send your stuff here. Okay. I think in this case, man, I wish they would have put like a diagram for these things, just so I can see what they're talking about here, because I didn't read the whole like chapter. So I'm trying to load the context of what they were meaning here.
They also talked about tunneling from IPv6 to IPv4 for some context.
Yeah, so I guess what they're trying to say here is, so I guess the question really becomes first, like, do you all know what NAT is and like why it's a thing or what it is?
yeah, I think they covered it in this chapter as Pat.
Okay. Did they cover Pat?
Yeah, they brought it up.
You were just at it.
I was just at it. Of course I was. Sorry, I'm
type in like pattern instead, or like the full name.
Was it here in IPv6?
Around there. Yes.
I don't remember if that's like a IPv6 specific thing. Hold on, I'm just trying to look real quick. Let me know if you
I
all
didn't
find
think
it.
it was.
I didn't think it was either, but now I'm questioning myself. Okay, I don't know where that is. All right, anyway, let me draw something real quick because I want to show. TL draw? Yeah, TL draw. Get rid of this.
The quick way to delete it, I found, there's no like delete all, but you can do Control A delete and it'll delete everything because it'll select everything.
Oh yeah, so much better. Thank you. So NAT is essentially like you have your home network, right? Like this is your home network down here, right? And you have like devices on your home network, and like your home network's like IP address is like 198.0.0/24, right? Which was what we used before. And like out of these IP addresses, like let's say this node has like .7, this node has .10, this node has like .32, and this node has like .45. Like these are the IP addresses they have. And you have a router on your network. I think this is the normal view for a router. And this router, is giving you internal network, right? We generally refer to this side of the hop, like this side down here is called the LAN, right? Local area network. Now, on the other side, there's like the internet, right? This is the internet, and I'm going to just call it INET in the worst possible spelling. And your ISP lets you communicate across the internet with what's called a public address. So I'll call this public address like, I don't know, I'll just call it 1234 just for simplicity's sake. And this now is the WAN side, right? So the router is a bridge between your WAN and LAN. Now, when clients talk to you, right? So if I am a client way on the other side of an internet, so if I'm over here like in my own network, right, with my own router and whatever, and I'll draw it smaller. Actually, I can get rid of those. if I am here,
I do it too, but keep in mind there's an arrow tool and text tool if you don't want to draw it out.
oh, nah, okay, we're in it now though. So keep in mind, like, this is my LAN, right?
Yep,
This
I
is
do
me.
the same thing.
This is happy old me on my, like, internal, 10.0.0.0/24 network, right? That's me. And I have IP address like .7. And my WAN address is like, 5, 6, 7, 8. I can't draw 8. Okay, there we go. So I want to communicate to you. So like this node, I'll draw you in purple. This 32 node wants to communicate to me on .7. Obviously, I can't send a packet from 192.168.0.0 to 10.0.0.0. I can't send them to those addresses because those are private addresses, right? And I'm just making sure the stream thing
Right.
is correct because I think, okay, no, we're good. So I can't send it because that's private addresses. So I have to send it out through my router or whoever this .32 is. They have to send it out through the router and over to me. So what they're going to do is they're going to say, hey, like, I would like to send a request from, from 192.168, whatever, to this public address here. Oh, I thought I was purple. I'm not purple. Hold on. Let me switch back to purple. My bad. So your purple client is going to say, hey, I want to connect to address 5, 6, 7, 8. Let's call it port. I don't know. Let's say my service is listening on port 123, right? You're going to connect to this address. And when that connection goes out, right? When it hits your router, so at this point, you have the sender. I should like type this out. I feel like it would be faster if I typed it out. But the source address for your connection is like 192.192. I'm typing this out. I'm sorry.
Press the T key and it'll
Oh,
open
thank
up
you.
the T and then click somewhere and start typing.
Okay. Yeah, I think that would be better because I want to like make it look pretty. Can I? Cool. That looks good. And make it like better font. Can I make it bigger? Yeah, bigger font. Okay. So when your packet goes out, you have it as like 192.168.0.32, and you get randomly assigned some like NAT port. So let's call your random NAT port like, 31234. Okay, that's your NAT port. And your packet is going to go to, can I make this text box bigger? How can I make this bigger? Better. Okay. And you're going to send the request to my IP, right? 5, 6, 7, 8, port 123. That's where you want to send, right? So at this point, this is what your source and destination look like. However, obviously I can't respond back to you on this 192.168 address because that's a private address. When this packet hits your router, it's going to translate this into a 1, 2, 3, 4. It's going to pick another NAT port. So let's call this NAT port, 41234. And then it's going to
These
do
ports like UDP and the
usually
UDP TCP ports.
it would be UDP TCP. Let's say this TCP here. So let's call this like at client, or let's call this source client. Let's call this source router. So at this point, the packet's at your source router, right? It's here in the middle. And your router does a NAT translation. It says, hey, obviously your private address of 192.168 can't possibly be the source address, because then the destination that you're sending to will have no idea how to reply. So what your router does, it says, hey, I'm going to translate that address for you into this 1234 address because that's my public IP, and I'll pick a random port, right? I'll open up a random port. Then when the packet makes it all the way to, where am I? When the packet makes it to my router gets the packet. It says, oh, great. I've received a packet for 5678123. It knows that port 123 maybe is forwarded back to my 10.7, whatever. So it sends the packet back to my 10.7 and I service the request. But now to reply, I need to send the reply that's like this. 7, and I'll say like, from port 123, I'll send a reply back to your thing. So which is 5, 6, 7, 8, 1, 2, 3. Or sorry, I bounced that back. It should be this one. Boom. So my client now is going to say, hey, I'm going to send you a response. And technically I don't have to use port 123 here. I could have used like another like randomly assigned NAT port. And it's going to send it to your public address. My router is now going to get it and say, hey, dude, you can't possibly send it as your source, right? Let me do a NAT translation for you. And it'll do this. Boom. And I'll just call this one another like 6, 1, 2, 3, 4. Boom. So now this is how the translation looks like. So really, it's just our routers kind of communicating with each other on behalf of us, right? Like my source, your source IP of 192.168.0.32 gets NAT translated into this 1234 address. The packet gets sent to me. I get it and I deliver it. I send it back to you to that router's address. And my router also does NAT to say, hey, if you want to reply again, here's where you come back to. So it's like when we're doing this back and forth, right? And in this case, actually, I should have sent this as 123 because that was the original port we were going to. But this translation happens all the time. That's in fact how we get out of networks that are behind a router, like a public router. So any question on this so far? I know it's a little hairy to follow, but like that's how it works. You can kind of ignore these like random ports I'm generating for you. Technically speaking, like both sides of a TCP connection have to have a port, right? Because how else are you gonna like talk? When you send a connection outbound, let me see. I show curl, I don't know, -v https:// oxide.computer, and like I'll send I don't need the output, so I'll send that to dev null real quick. Dev null. Yeah, that was good. You see here how I like connected to port 443. So I connected to Oxide over port 443. I thought curl showed me my, I thought it showed me my client port. Damn it, it didn't show. My bad. I thought it was going to show me like that randomly generated client port. How else can I show this to you real quick? Is there a way to do it? I forget off the top of my head. One second. There was a way to show like what your client port was, and I forget what it is now that I'm on the fly. Netstat. This is fine. I don't know what this is actually going to. Yeah, this is fine. But basically, whenever you make a connection outbound, your like local server has to dynamically generate a port, so that way it can like open the connection, and that port's going to be used to receive the traffic coming back. So that's what like that randomly generated port is. If I didn't have a port, how is my router going to like talk back to me, right? Like how is it going to send me back the response? But once the traffic gets to the router, it has to get translated to the public address, so that way it can flow over the internet, because the internet has no idea about your private address. So that's NAT in a nutshell. Sorry, I know it's very long-winded. I wasn't prepared to explain NAT. It's fine. In this case,
like traceroute to see what ports they're on.
No, because that'll show me the hops. There's no actual like traceroute uses ICMP, so there's no TCP connection being created there. But there was a way. I could have wrote a little program to do it, but I thought I can do it like off the top, like off the rip. I really thought curl was gonna give it to me. Let me just see something real quick. Yeah, it doesn't show. That's annoying. Usually there was a way to show it, but it's okay. So
Yeah,
yeah. Good.
Oh, yeah, that was a good explanation. Better than my networking professor. He was. It's that was an interesting couple weeks. When it
Yeah.
comes to tunnels, is it almost like a dedicated address that the client or server uses to communicate between the two. They each, have dedicated
Correct.
host that they use to communicate, and like that's just a quote unquote tunnel. It's just pretty abstract. It's not anything too
Correct.
special other than the fact that we're just using these dedicated IP addresses to communicate.
Exactly. So like, I'm sure I got something wrong in this NAT translation table that I drew on the left-hand side. I'm sure someone's gonna be like, well, actually, Matt, you just, I'm sure I typoed something here, and that's fine. But you get the concept. In the
Yeah.
tunnel case, I think how it works off the top of my head is I think your service listening in the back end will establish like an open, like a connection, and it'll be listening on some NAT port, and then you are going to just send to that, right? So like, let's say that you're sitting here behind your 1234 router and you wanted to open up a tunnel. You'd say, hey Matt, you can always contact me at port address 1234. I don't know why my shit got thicker. Oh, I think I hit this. Sorry, let me clear that. I was like, that was really thick. That was thick, boy. Too thick still. Oh no, what did I do? Please send help. I can't TLDR draw. I messed up the draw. Okay, that's better. But why is my color incorrect? I'm scared. I don't know what I'm doing anymore. Oh, okay. I see. I found out. I'm smart again. Okay, we're good. It was bad. Okay, sorry. In the case of a tunnel, you'll just be like, hey dude, I'm listening. Oh god, this is so badly drawn. I'm listening on port, 50,000 over here. If you want to like talk to me, that's like my NAT tunnel. I don't remember though, and this is where I'd have to look it up, or you would look it up. I don't remember though if there has to be some service somewhere in the internet to facilitate the tunnel. Cause like you can't just tell your router that you're listening on some public port. The router has to do that. So I think what actually has to happen in the tunnel case, and mind you, I'm speculating here. I don't know. I'd have to look it up. But I think what has to happen is there's some service sitting out here in the ether on the internet. You open up a connection to this service, right? And I'll draw this in in like another color, like I don't know, green or red. Let's do red. And let me get rid of this shit. Oh, sorry, wrong thing. There we go. You open up a tunnel, like you open up a connection to this service, right? And that gives you the NAT translation that we just talked about, right? And then you open up the other client opens up a connection to this service too, and you communicate via that, and that's your tunnel. And that service knows both sides' NAT address, and a tunnel is now open. I think that's how it mostly works under the hood, but I could be wrong. But I do think that's how it works. Like ngrok and such that have like tunnels like that, I think that's how they operate.
Yeah.
But
I'll have to look more into that because I do use ngrok for webhook testing. So I'll have to look at that. Because I also with like if I'm just thinking of like if you're a hospital or if you're dealing with very sensitive information, or you're integrating, two services where for whatever reason they have a special use case where they need a dedicated channel to communicate.
Yeah.
Tunnels would be good, but just curious how they're implemented. So
I
definitely
think
look into
that's
that.
how it works. This has to be how it works. Cause like the idea is that firewalls, like this firewall graphic that was here, wherever it was, this is not a bad graphic because firewalls generally prevent incoming traffic, right, into your system. And you would have to explicitly open a port if you wanted it to be accessed. However, outbound connections to the internet are allowed, obviously, and the responses back are allowed. Because otherwise, how would you ever communicate with all these things on the website or on the internet if your firewall blocked every response? You know what I mean? So there's a concept of in TCP called like established connections. So if I connect to like, foo.com port 80 and a response comes back from foo.com port 80, my firewall has to let it through because it's the response for an established connection that I've made from the internal. So that's, I think, the foundation of tunnels, where I'm connected to a service, so my side of traffic is good, my request and response is good. You connect to that service, and then that service brokers us to connect to each other, and it basically says, hey, Matt's NAT port is this, your NAT port is that, go ahead and just talk to each other. I think that's how it works under the hood, but I would encourage you to like research it.
Yeah, I'm gonna look more into that because I use ngrok pretty extensively, so I'll have to do that.
Yeah, it's a
It
good
says they
good tool.
encrypt with TLS through the.
Oh yeah, I mean there's the TLS part of it too, which I wasn't really covering.
Oh yeah, just because they brought up security.
Yeah, and here I think this is a good. Let's see if this works well. Yeah, this is like the SSH tunnel concept, where it's like we establish an SSH connection over port 22, right? And then from there, any request to localhost 8080 gets put over the SSH tunnel, and then there's something on the other side knowing how to speak, how to respond to that. So again, like this is the same concept, but SSH is that like service that we both connect to, to do the tunnel. Good question. That's a really, really good question, and one that I haven't really thought of hard. I haven't really spent much time thinking about it, so that was like difficult for me to answer at first, because I was like, how does a tunnel work? It's one of those things where you use them and you don't question it.
Yeah. Whenever I keep reading them, I'm always curious because similar situation.
No, that's really good. Thanks for asking
the
that one.
docs here.
Yeah.
Might be worth a quick read.
Yeah.
If you haven't already, of course.
I was hoping that they had I wanted them to have a picture on that doc, but it's fine. Yeah, NAT and all that stuff is hard to wrap your head around. I encourage everyone, I don't know what programming languages you all use here, but I encourage everyone to use their raw Go net package, whatever. Every programming language usually has a raw like net package that knows how to speak layer 4, right? TCP UDP. I would encourage you all to write a server, like a client and a server, like a TCP client, TCP server in whatever language you use, and print out like the connection details. Because then, you would see the like client port address and the server port address and how they like both do a request response, and you'll see what I'm talking about. This is not like necessarily a tunnel. It's just like that port that I was kind of drawing up on the document here, where I was just like kind of hand waving and saying, yeah, this port gets generated. Like that's where it comes from. Your OS has to dynamically, like it can't possibly facilitate communication over TCP without having some source port to like send the response back to, So the first thing it needs to do is say, hey, Matt, you want to make a connection to google.com? Great. Your port is 31234, and make the connection. Man, y'all are making it hard for me today. I like it. Any other questions?
And with the heavy hitting questions.
Yeah, no, I enjoy it. Networking is arguably one of my weakest parts, because like I've never really done network administration to the extent of other people, like configuring switches in a big ass data center. I never really like done that stuff. So networking is arguably like my weakest stuff. So I like to talk about it. Any other questions on networking?
They mentioned a bunch of things about, like on a similar note, they mentioned VPNs and how they're very often very different things depending on where you're running them. Like a browser VPN cannot possibly be as powerful as like dedicated software that is more lower level. I guess I can't just say dedicated, but like lower level access to networking things.
Where do they do this?
That's a good question.
Security, virtual private networks. Yeah, I mean, and that makes sense, right? Because like your browser, when you look at like the OSI model, so OSI 7-layer model, yeah. When you look at the OSI model, whatever one, doesn't matter. Like your browser sits all the way up here in the application layer. It can't possibly like tell layer 4 what to do, right? All your browser can say is, "Hey, I want to create a new TCP socket." It doesn't have the ability to listen on specific ports or whatever. It can just request those things. So if you're running a VPN at like the layer 4, layer 3 layers, they have more direct access to what they can do, right? Like how they can listen on the network and how can they respond and blah blah blah. I think browser VPNs also have to like do some tunneling approach where they have to connect to some VPN service and like establish a tunnel and do it that way. And at that point, like you're not really, you have to trust whatever service you're connecting to. So I don't know what the author says here on it, but TLS base. Yep. True VPN service. Yeah.
Oh, they also say a small Java or executable component through their web browser, and I feel like downloading Java for my web browser seems like an outdated concept unless I'm missing out on
I think that's
like
more of an
real
outdated
Java
concept, yeah.
still.
I think like nowadays if your browser is offering you a VPN or something, it's probably just doing that over TLS and connecting to some service somewhere. And basically the architecture is kind of like a tunnel at that point. But if you want like a true VPN, you need some privileged like service on your system to like do that, you know, because how else is it gonna bind to the network ports that it needs to bind to or run and do that? Like I have like that's how I connected to the Oxide thing before. I have a VPN set up on my system. I'm actually connected to it right now. I think I can show you a little bit of it. Like somewhere, like you see here, I have VPN turned on, and this VPN is like a VPN configuration that when I turn it on, it connects to the VPN at Oxide. It uses like my certificate and whatever to authenticate me. And then now, if I want to send traffic to like the private IPs at Oxide, I can do that because it's basically the VPN service created a route. I think I can show you. Yeah. So the VPN service created these routes here. See all these beautiful routes? These are all created here from a VPN service, except for this one, but whatever. Or yeah, that one too. And anytime I send a packet, you know, or send some request to this 172 networks, this my VPN tunnel is used instead of like my default like network here, right? Because I'm on this 10 network. So if you were running this in a browser, how could your browser ever like modify the routing table on your system, right? It's just too high level. It can't do that. So it needs to be a system level service to do real shit. Real shit.
Okay. And now that we're talking about that, there's a bunch of words that I have in my brain that are like similar sounding, but not quite exactly sure. Like I hear internet gateway, which seems like just like connecting your network to, or like connecting, like just exposing your VPC to the internet.
Yep.
Okay. And then like I hear virtual private gateway, which seems like the same thing with like a VPN.
Okay, let's talk about internet gateways for a second. What does Amazon say? Because Amazon's the one that came up with this stupid crap. Internet gateway versus NAT gateway. So generally speaking, there's like two devices that you can use, or two concepts you can use in Amazon. An internet gateway and a NAT gateway. So like I guess this is probably a good thing to show. I just dox my email address. That's fine. That's one that is public anyway. You have a concept of VPC in like AWS, right? Which is a virtual private cloud. Dumbass name, but really it's just like a way to have subnets in like a network, right? You can create a couple different types of subnets on AWS. You can create like public subnets and private subnets. Public subnets are ones that can get public IPs, right? They can actually hold on to a public IP and go out to the internet. And the way they go out to the internet is via an internet gateway. So an internet gateway sits in front of your public subnet, and your public subnet uses that internet gateway as its like default route of how to get out to the internet and how to get replies back. So that's the internet gateway. Think of it in my case, if I show you my routing table, IPR, my default gateway is 10.0.0.1, right? 10.0.1.1. Like that's my router in my basement somewhere. And that is essentially my internet gateway because like I'm going at it, right? If I were a public address, right? If this was a public address. For NAT gateway though, NAT gateway has the additional requirements that you need to perform network address translation, right? You need to do NAT stuff. And that allows a private subnet to go out to the internet. Still via the same internet gateway, but when the reply comes back in, it hits the NAT gateway, gets the address translated back, and goes back to private. So like that's the difference between those two. And I think that this TLDR like gives it pretty well. If you want to read that real quick. So does that at least help answer your question?
So it is a public IP that then is forwarded outwards.
Right. And different cloud providers kind of use different terminology for these things. So I know it gets a little frustrating to follow. I think this is a good point to read that I think people should understand. If you go to AWS and you create a VPC, even if like you have a public like subnet or whatever, if there's no internet gateway, how the heck is the internet going to like talk back to you? You know, how a response is going to make its way back into your VPC. You need that internet gateway. We have this in Oxide too. We have a concept of an internet gateway where your traffic goes out so that it can come back in. I'll be honest with you, the whole AWS networking model took me a long time to wrap my head around. I remember being thrown in here. I actually had an interview question. Like when I interviewed for a company sometime in the past, they wanted me to use Terraform to create a VPC with a public and private subnet that has full like, you know, internet connectivity and all that. And I was like, I don't know how to do that. I remember that. Okay. Any other questions?
Do we talk about the virtual private gateway?
Did we? Is that in here? I don't even know if it's in here.
It's not in here. I don't think it is. It's just more AWS words.
Oh, that I don't know. What does that mean? I can look it up though, because
That's what I was
AWS
thinking,
has
like,
many
that
words.
one's just like a VPN on the,
Virtual private.
yeah, we have a
gateway.
VPC, VPS, VPG.
What the hell is this? I don't even know what this is. Virtual private gateway. Oh, I guess this is a way to connect VPCs to another, like a VPN. Sure. I don't know what the AWS means with this. I don't use a lot of AWS anymore. Oh yeah, it's just like a VPC. It's a VPN between your network and AWS VPC. So it's like direct connect, I guess.
Direct connect without the direct connection.
Dude, they use so much terminology here. Customer gateway, Jesus Christ. No wonder why nobody knows what to do in the cloud. They don't freaking use any good terminology. This is sad.
Overcomplicated.
Way overcomplicated. Like, way overcomplicated. If you were to interview me right now and be like, Matt, what is a virtual private gateway in AWS? I'd be like, I don't know, dude. I don't know what this shit is. Wow. Any other questions, Jacob? I know you're studying for your AWS stuff, so I know you have like AWS specific questions.
I'm not studying for anything specific now. I just was like looking at some, I mean, like architecture stuff, which of course has AWS in there. It's like, how
Gotcha.
does this all relate?
Yeah, there's
I definitely could at
there's a
some
lot.
point, but yeah, I don't. I like doing this stuff rather than memorizing like pricing and various other things that I won't need, you know?
There's this book.
I wonder if.
Go ahead.
Oh, I was gonna say, I wonder if AWS has like a packet tracer equivalent to like, you know, learn and build out VPCs and stuff like that. I'd be curious if they have that. Let me look that up.
This TCP/IP guide book is very good. It'll like really go into the details of networking. It's also a big read, but it's free online, or you can buy the book paid through Amazon. But this is a really good book that goes over like all the networking stuff. Very helpful. Cause like, we're taking what, 45 minutes to an hour or whatever to talk about networking, but there's so much in there that it's hard to like cover it all in one sitting. So I'd recommend people to, go read books. Any other questions? I think we covered pretty much the basics, right? We went through like physical network earlier. We went through the OSI layers. We talked about like addressing for, IP addressing, sockets, blah, blah, blah. We talked about routing a little bit and how like, packets are routed across the network. We didn't really talk about DHCP, but that's fine. We talked about NATs and tunnels and other things of that nature. Any other networking questions?
I had a clarifying question of what CIDR is, and if I'm understanding correctly, it's just IP address with the net mask on the end. So to clarify what exactly it is.
Yeah, CIDR stuff is like, I think it's under here, right? Where did they put it here?
It's CIDR. Okay. What was that? CIDR.
It's the same thing. It's classless interdomain routing. I think that's what it's called. Hold on, let me just look for CIDR. There we go. So way back in the day, this is just kind of a historical thing. Way back in the day, there were different classes of addresses, right? There was like the class A, class B, class C, whatever. And those addresses, where did they show the byte boundaries? Hold on, sorry. Yeah, this is fine. You see like the byte boundaries. An IP address is just 32 bits, right? IPv4 address is 32 bits grouped into 8 bits at a time. Each 8 bits is called like the octet essentially, and class full addresses were addresses that ended on one of the byte boundaries, right? So like at the 8-bit, at the 16-bit, or at the 24-bit, or at the 32-bit. And that was like the one way you can like assign addresses. You can get a class A address space, you can get a class B address space, and so on and so forth. And that's just what it was back in the day. Obviously that's wasteful, right? If you need 3 addresses and I'm like, hey Jacob, here's a class C address with 255 addresses, I'm just wasting addresses, right? If you only needed 3 and I'm giving you 255, that's silly. So they were like, let's stop doing that. And the term CIDR was born, classless interdomain routing. And this allows us to break up addresses at not the byte boundaries. So instead of having to have a /8, a /16, or a /24, you can have like a /22 if you wanted to. And that allowed you to be more specific with the addresses that you're doing. So that's all that is. Any
Yeah, that makes
questions?
sense. I just remember one of the
Any-
many things that I did not understand was like just type in a number there and
Yeah.
see what it is from like
I
whatever docs tell me to do, and it worked.
that IP calculator that I brought up before, IP subnet, yeah, whatever this one was, Jody's, yeah, this one. This was really good because if I show you like if I take like a /24 and I break it up into like /26s or something, it shows you like all the networks that come out of it and shows you how like to subnet things. I recommend people playing around with this to see like how subnetting works and whatnot. It's pretty nice. It also shows you the class of address, which doesn't really matter anymore, but it's there.
So then, what are the trade-offs of like a higher or lower net mask?
Higher being like higher number.
Yeah, exactly.
Yeah, I mean, like, so for example, if you're going to create an AWS VPC, right? Let's say like you're going to create like 10.0.0.0/16/16. You have 65,000 addresses that you can use in this class 16, right? But then from there, you want to create multiple subnets, right? You want to have a subnet for your databases, a subnet for your private networks, public networks, whatever. You now need to like chop this whole /16 into more networks. And let's say you wanted to chop it into /24s, right? Just to keep it clean. If you took a /16 and chopped it up into /24s, you can get however many subnets this is. I think this is let me scroll to the bottom. I think they have a summary. You can get 256 subnets. Each subnet can have 254 addresses. So that's how you can like chop up the network. And it's useful because like in cloud networking, a VPC, whatever address range you start for your VPC, that's it. You can't make it bigger or smaller. You can't make it bigger if you messed up. You have to create a new VPC to do that. So I guess that's the significance, like thinking about your network architecture and what you want to do. I would say that's probably it.
Yeah, it makes sense.
We have the same concept too in Oxide where you create a VPC and same thing, like you have a VPC with this address space, and then we just create you a default subnet in the VPC. So that way you like, you can launch instances without having to be a network master. Cool. Any other questions on our last chapter?
I think that's about it for me because, oh no, I have one more. Okay. So
Yeah.
they mention ICMP, and as a security measure, they say you should typically ignore any ICMP packets. So then why do so many sites not do that? Like for example, Google, you can ping Google if you want.
That's a good question. I don't know why so many people say like you should drop traffic on ICMP for security. Like I guess it's an enumeration thing. Like if your site responds, like if your IP address responds with a ping, like for example, if I ping like, my default gateway here, it's responding with a ping, right? It's responding with ICMP. That lets me know that there's something there, right? And now I can target that thing and I can enumerate that thing and find out more about your network. Great. Sure, I can enumerate things and whatever. You can see what's on my network. Fine. But like even if I turn off ICMP, I can still do the same thing. I can just nmap your network and like, enumerate all the different ports and whatever. I can still do it. So I don't know why people are so adamant about disabling ICMP for security reasons. I actually like ICMP on for debugging reasons because there's times where things are broken. Sorry, I dropped something. There's times where things are broken and I'm like, I need to troubleshoot my network. And if ICMP is either disabled or filtered out, I can't troubleshoot my network anymore. It's hard. And I'd prefer ICMP to stay on, but your mileage may vary.
The book recommends turning it off when you do want to debug. or sorry, turning off the thing blocking
Yeah.
ICMP.
Yeah, I generally like to keep ICMP enabled and not blocked, so that way I can do debugging. But again, your mileage will vary, right? Like in my home network, ICMP is on. I can ping whatever address I want in my home network. Great. If someone came in here and broke into my house and tried to like enumerate my network, okay, you already broke into my house, so you know what I mean. You already got physical access to the network, so of course you owned it. In more high security stuff, that's people are very like adamant about not enumerating things. Maybe they disable it, but I don't think it's necessary. This is one of those things where it's preference, honestly. I don't see like I can understand both sides. I just prefer to keep it enabled for debugging. Think of it this way. The people that are telling you to disable ICMP and like filter it out are often security people who are not going to be paged when shit goes down. So they don't care. So they're always going to tell you to like disable it because they're not going to be the ones that have to deal with it when it's broken. So should I block ICMP.com?
Yeah, you could probably do. That's the first thing I found when I googled
so
it.
good. Should I block ICMP? No. Yes.
Yeah,
This person
you could
gets
do
it.
something different in the middle. Like you don't have to block it, but you could like rate limit people going at you with like super low TTLs, and you could block
Yeah.
other. I mean, I don't know all the ICMP verbs or whatever you call them, but like keep echoes there and turn off other stuff that could be
Yeah.
dangerous. Who knows?
That's also a good thing. You can block it for certain hosts, but not for others. And that's also something you can do. And I think that's a valid approach. Like I'll block ICMPs coming from the external network, but I'll allow it in my internal network so I can like troubleshoot. Like that's fine. I don't know. I think people just get a little wild up about it. I remember this time too when I was at a job like maybe like 5-7 years ago now. People were like that. They were like, "You gotta disable ICMP. It's a security risk." I'm like, "Show me the security risk. I can find out what's on your network. You already know what's on my network. Like you can still find this out. You know, you can't hide SSH. You can't hide your web server. Like obviously they're there. So what good is having ICMP blocked? Like what is that really gonna do?" But whatever. People are people. Ooh, there's a typo here.
I found multiple typos in this book.
That's because,
And
it's a
always
PDF.
sad when they're not like open source.
Yeah, I know. I mean, I bought the book. I
Just
have the
fix
book
them.
behind me. I like this book. I also bought another book wherever I put it. Any other questions?
I don't have any more here because I feel like a lot of this is just like stuff will reach out when I need it, maybe.
Yeah. Okay. Anyone else questions
I'm glad
about?
to hear any explanations of stuff though. 'Cause that was good to learn more about NAT. That.
Yeah. I don't. I'll just like look through this one more time. OSI 7-layer model, right? Everyone should be aware of that. TCP/IP. I'll just go through like some gotchas. A common misconception is that there's like 65,000 ports on your system for listening, and 2 to the 32. No, what is that? 2 to 32? Yeah, I think it's 2 to 32.
2 to the 6.
2 to 16? Is that
2 to the 16.
Okay, thank you.
Yeah.
A common misconception is that there's only those 65,000 ports to listen on your system, and that is true, but it's per TCP and per UDP. So technically, you can use 65,000 ports on TCP and then another 65,000 ports on UDP, and technically have 128,000 or whatever TCP ports, ports open. 65K for TCP, 65K for UDP. So that's a common misconception. Networking. Go ahead.
For that common misconception, then, so for the lower like 1024 ports, does that apply then? So there's really 2048 like privileged ports. So one set for TCP, one set for UDP,
Correct.
or
Although
no? Okay.
it still applies there, yes, but those ports generally use both TCP and UDP for certain things. Like HTTPS uses
Mhm.
TCP and UDP, like, you know, for certain
Right.
things. Like the newer versions of HTTPS at least are trying to use that. So I wouldn't
Mhm.
advise listening on TCP or listening on UDP port 80 when TCP port 80 is already used by your web server. You know, I would like
Mhm.
leave it open just in case they want to use it for something else. DNS is a very common one. People think that DNS is strictly UDP, but actually it speaks TCP as well, especially for larger responses. It switches to TCP for those. So you need to open up port 53 TCP and UDP for that. But yeah, so that's just a common misconception that if you hear people like, you can only listen on 65K ports. No, that's per protocol, per TCP, per UDP. What else? You already know IP addresses and all that stuff, and we kind of walked through earlier in the video about like how packets go across networks. Good. We covered MAC addressing for the hardware. We covered IP addressing for your device. We covered ports for your service. So we covered all that. Oh, one misconception about MAC addresses is that they have to be globally unique. Oh my God. That is also untrue. They have to be unique within your collision domain. So within your layer 2 network, they have to be unique there. Because MAC addresses only matter for layer 2. So they only have to be unique there. So technically, if you and I are in different parts of the world right now, we can have the same network interface with the same MAC address and we would be fine because we're not on the same layer 2 domain. What else? So that's done. IP addresses, we went from classes and subnettings. We did that. That doesn't really matter. We'll skip IPv6. Routing tables, we showed you routing tables. Routing tables, they match the most specific route they can to determine how to route a packet. DHCP we skipped. Security issues we kind of talked about a little bit. You know, VPNs and stuff, we talked about that a little bit. We didn't really cover network configuration, but you can, you know, I don't think any of you are going to be Linux admins like for your career, right? We're all software engineers here. If you ever need to learn how to configure a network on Linux, you can do that, you know, in your spare time. I showed you some of the IP commands to show like the routing table and to show the address for devices. FreeBSD we've been skipping. Oh, network troubleshooting. You all know how to ping, right? You all know how to do a ping and do an ICMP check against something. I just showed you. Trace route is also another one. So trace route, trace path. I can trace route through like my network and get like the network hops it takes. Since some people do block ICMP, trace path doesn't always work. You can do dig for DNS. So if I wanted to like dig, I don't know, google.com, I can do a DNS request to see if it works. So those are some other common network troubleshooting things. Packet sniffing, you can do TCP dump and Wireshark to sniff packets. If you do this, you need to be root user or admin user, and you're going to get a shit ton of data. So just be careful with that. But often there's been times where I've had to sniff network traffic to debug an issue. Network monitoring, okay, not really necessary for us. Firewalls and NAT, we did a whole discussion on NAT. We didn't talk much about firewalls, but I'll just briefly mention the firewall's purpose is to like just filter out network traffic, right? Either drop it or not. And the way it does it is based on IP and port. So it knows how to do that. And we talked about cloud networking a little bit, VPCs and stuff. Whew, okay, that was a lot. Sorry, I kind of wanted to speed run that real quick. And I didn't know we were going to record this long, so I'm so sorry for keeping you all here.
It was expected from the gigantic TCP chapter, I feel.
No, this is great. And I love that we like, that's why I wanted to record it, because you know, like the resume, the people that like ask for resume reviews all the time, and you're like constantly telling the same people the same, you're constantly telling different people the same feedback because everyone's kind of doing the same mistakes. That's why I just wanted to record this. So that way, like, it's there. people can just refer to it if they want to, and like it's out there. I don't have to be like explaining networking for the 100th time. I can just be like, here, look at this, have fun. So that's another. This is a selfish reason for me to record this.
I feel like it's not all selfish. Like, for example, my blog, I can reach so many more people the same feedback that I typically give
Yep.
than if I just told the same people the same thing in like 20-minute increments.
Correct.
You can only help so many people, right?
This is true. You can only help so many people. Plus, I need the hours on YouTube, so you know, I need to do that. So this kind of helps kill two birds with one stone. We're doing it. We're almost there. We're doing it.
How
What else?
far off are you?
I think I need like 1,000 hours of in a year, like 1,000 watch hours. So that's like, you know, if 1,000 people watch 1 hour. So we're getting there. It's been going up. I think last week I needed like 1,500. So I've been doing the thing. So I'm excited. I also have some YouTube videos that I'm gonna actually
Doing the
release.
thing.
So that'll be fine. I've just been busy, man. I've been busy. Okay. Any other last minute questions? This is the last book club meeting for this book. Again, I'll reiterate to people that may have not been there. Our goal was to just read as much of the book as we can in 1 month. And that was about half the book. So we went through about half the book in 1 month, and we kind of cherry picked sections and stuff to read. If in the future we want to go to the next, you know, further chapters for some reason, we might, but there's no guarantee. So any questions before we call it? Also, I've been fidgeting with this thing in my hand.
What's the next book?
I have no idea. I honestly have no idea. I've been reading, I mean, it's a good question. I've been reading philosophy, software design. I've been reading this book. Wait, no, this is fine. I've been reading this book. This is a good blog, so I'll link to it. This has been good. It's a light read. It's like, where's like the normal book type for this? Like the normal book website. Whatever. We'll go to Amazon real quick. So this philosophy of software design, I've been reading this. It's only like 190 pages or something, 200 pages. Really good book. I have Computer Systems, a Programmer's Perspective. Yeah, I just bought this book that I'm going to read in my spare time, but this is like 1,000 pages. This is a
That's a textbook.
thick, yeah, this is a textbook. So I'm going to read this in my spare time with like for like deep studying. And then from there, I've been reading more Rust books. So I'm personally going through Rust for Rust Stations. So yeah, this one, Rust for Rust Stations. I'm going through this one. And I'm going through, what was it? Damn. Zero to Prod, thank you. I'm going through
I've
Zero
been
to Prod.
liking that one. I read the first part and it was pretty nice.
I just started it, so I'm like getting there. I wanted to finish the
was
other
pretty
books that I had
impressed by
first, and then go through it. So I'm going through this one. So that's kind of where I'm
Yeah,
at with books.
That's my problem too.
I like
Good stuff.
reading. I don't know. I like reading and understanding knowledge. I've been doing a lot of chatting with AI, you know, after study sessions and stuff, just to get more, you know, more knowledge and more experience and more stuff and coding things. I also started using like the AI customizations, you know, like how you can tell the AI how you should behave or whatever, like customize it to your liking. I've been using that, and it's been helping.
Prompts, yeah.
Yeah. I've been doing that, and it's been really nice because I don't know, the default is like too wordy, you know? And I don't need that.
Yeah.
I just need, you know, just give it to me straight. But I don't know. That's kind of that.
It's a really good study buddy.
Yes, it's so good. I don't understand how people don't use AI for that stuff. Like even just I don't know, even Chat GPT like logged out, right? Like I don't even have to log in sometimes. Even just the logging out of this, and I just ask it
Yeah.
like a question, like describe NAT tunnels in networking or whatever. Even just this is helpful. I just use this sometimes when I don't want to log in.
Yeah, I think the base model's 4.0 now, so it's definitely
Yeah, it works.
good. It was really good for college notes. So if you were in college and you had like the professor's notes talk about like the ultimate summarizer, it was
Oh yeah.
really good.
No, so I've been doing this. I don't understand, like I don't understand the AI hate in the knowledge learning side of things. I am constantly using AI to like learn and challenge myself and explain things all the time. Like if I were to log into ChatGPT or Claude or whatever, you would see my chat history is long, like how does the C compilers work? How does, Linux containers work and blah, just all this crap that I ask it, and it's wonderful. Because what's the alternative? Looking it up with a search engine and then going to some random site that has 50,000 ads on it and is a nightmare and no real answer? Like, that's not fun.
Yeah.
So, I don't know.
Yeah,
I like it.
I enjoy it.
So
I
I
enjoy
think
the
people should
process
use
of
it.
looking through various rabbit holes sometimes, because then you find all kinds of new sites and niche blogs that you can find more content from later, which you don't really get through AI. You're just at that point you're letting whatever the AI is trained on or whatever the makers have decided is good for you to be the thing that you look at. And then that makes it hard to find new things because it's trained on older data.
Oh, I think this works. Did this work? Do you see me big now? Do you hear yourselves?
Yep.
I have like a eyelash hanging right here and I can't get it. It's gonna bother me. But yeah, no, thank you all for going through this with me. Honestly, it's really fun. I mean, I hope it's valuable to you all too. Hope you're learning things and
Very valuable.
being
Very
inspired to
valuable.
learn. That's all I care about. I like helping out where I can. And thank you for helping me get my
That was
hours up.
extremely helpful. I'll gladly do it again.
Yes. Oh,
Same.
we got some subscribers for our podcast, so we're getting there. We got some subscribers coming in. I like it. We're doing a thing. We're making dollars. We're making dollars. Can't say hundreds of dollars. Can't say thousands. So we're making dollars, man. Oh,
Tens of
love it.
dollars.
Tens of dollars. Yes, tens of dollars.
Buy yourself a Rust book with that.
Oh, so good. No, it's
Or if
fun.
it's split like 8 ways, then I don't know. Get like a bagel. That'd be
Hey,
good.
I'll take a bagel, And now that bagel will probably taste great because it was earned, earned off of an employer, like not through an employer, earned with our own effort.
Also, because you're in Jersey. I mean, where else are you gonna get a bagel better than that?
Dude, I lived in Florida for a little bit, and the bagels down there were garbage. Like every time I'd fly back to New Jersey to visit friends and family, I'd bring back like a dozen or two frozen bagels because of how much I missed them.
Are you a bagel with lox type of person, or
No, I'm a nice bacon, egg, and cheese person with avocado on it or something. That's me all day.
ale or ham? Wow.
Or Taylor ham, yeah.
Yeah.
Depends on
Yeah.
how I'm feeling. How much of
Yeah.
my arteries I want to clog that day.
Oh, well.
What's the difference, right? Like, it is what it is. You just run
You
an
gotta
extra
enjoy
10
life.
minutes. Yeah. I gotta show you, like, there was a picture though that I posted on a review for one of the bagel spots, and it was just like so good. The bagel was just so delicious. And I loved every minute of it. But all right then. Well, I will go eat dinner and stuff. And thank you all for being great. I will continue to stream
See
other
ya.
things. And if there's another book club that we want to do or whatever, we can just do it. So goodbye,
Bye,
everyone.
Surya.
Sounds
I-
good.
Peace out.
Peace.
Yeah.